Hello, welcome to Easy Maths for Everyone. With Easy Maths for Everyone, concept simplified and success amplified. Solving previous year papers is important because it helps you understand the exam pattern, identify the high priority topics and improve your time management, thereby helping in developing strategies within the limited time. Also, it helps to enhance your problem solving skills and in boosting your confidence level by reducing the exam anxiety. Also, solving papers reinforces the understanding of core concepts and highlights the areas where you need more attention and revision. My humble request to you is, rather than watching this video, do solve the paper along with me. Do pause the video after every question is displayed, and once you are done, check your answer with mine. Hope you are ready with your pen and papers. Without further ado, let's get started. The paper we are going to discuss today is the board paper for 2024-25 batch, and the paper code is 65/2/1. To begin with, let's solve the sums from section A, which are MCQs carrying 1 mark each. The first question is, the projection vector of vector A on vector B is, see, actually there are two types of projections. Okay, so if you take projection, there are two types of projections. The first one is a scalar projection and the second one is the vector projection. Scalar projection is more like a length of the shadow. Okay, for example, if my vector A is along this way and my vector B is along this way, then the projection of vector A and vector B will be like the length of the shadow. Okay, so that is obtained by the scalar projection, but the vector projection is something different. Yeah, so let us see the formulas for them. So the scalar projection of vector A on vector B is given to be component of vector A on B, which is equal to A dot B divided by length of B. There is a trigonometric form also, is length of vector A into cos theta. This is also scalar projection only, and the vector projection of A on B will be equal to projection of A onto B equal to A dot B divided by length of B square into vector B. Or there is another form of writing this same formula, which is A dot B divided by B dot B into vector B. Both are same only. If any of these are given, then we can go well with this. See, the projection vector they are asking, that means the vector projection. So don't be carried away with the scalar projections given here in option B and C. They are not correct. So the correct option will be option A. Let's move on to the next sum. Sum number 2. The function f of x equal to x square minus 4x plus 6 is increasing in the interval. In order to know this, we have to find the critical point of this function given. So for that, we have to find the first derivative of this function and set this equal to 0, right? So let us take f of x equal to x square minus 4x plus 6. So f dash of x will be 2x minus 4 into 1 plus 0, which is equal to 2x minus 4. So let f dash of x equal to 0. That implies 2x minus 4 equal to 0. That implies 2x equal to 4. That implies x equal to 2, right? So when we consider the number line between minus infinity to plus infinity, there is this 2 here. So the function's behavior to the left side of 2 will be different, to the right side of 2 will be different, especially, right? Okay. So in order to know the behavior of the function, we can apply the first derivative test, which says take a neighborhood of the critical point. So the critical point is 2, we have just found it. So the neighborhood of 2 we can take like the interval 1, 3. So we can find out the value of f dash at 1 and value of f dash at 3. Depending on the signs it is taking, we can decide about this, right? So f dash of 1 will be 2 into 1 minus 4, because I am taking 2x minus 4 and applying x equal to 1, right? So this will be equal to minus 2, so which is a negative value, and f dash of 3 will be 2 times 3 minus 4, which is 6 minus 4, 2, which is greater than 0. So to the left side of the critical point, the function is decreasing, and to the right side of the critical point, the function is increasing, right? So the function is decreasing and then increasing. So here is the critical point 2. So it is a minimum point, right? We can say f of x is increasing to the right of 2 and f of x is decreasing to the left of 2. But look at the question here, on which interval the function is increasing. So 0, 2 lies before the point 2. So we can't take it. The function will be decreasing in this interval, right? And the interval given in option B is also to the left side of the point 2. There also the function will be decreasing only. And 1, 2 is also an interval which is to the left side of 2. There also the function will be decreasing only. Only 2, infinity is the interval which is after the point 2. In that zone only the function will be increasing. So option D is the correct answer. Let's see sum number 3. If f of 2a minus x equal to f of x, then integral f of x dx between the limits 0 to 2a is, we are going to use properties here. The first property we are going to use here is integral a to b f of x dx equal to integral a to b f of a plus b minus x dx. And the second property we are going to apply here is integral a to b f of x dx equal to minus integral b to a f of x dx. And the third property which we are going to use here is integral a to b f of x dx equal to integral a to b f of t dt. And the fourth property which we are going to use is integral a to b f of x dx equal to integral a to c f of x dx plus integral c to b f of x dx, where c lies between a and b. Now integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral a to 2a f of x dx, because we know that a lies between 0 and 2a. Now we are going to consider the second integral which we have here, this one. Okay, and we are going to put some substitution there. So consider integral a to 2a f of x dx. We are going to put x equal to 2a minus t. So dx will be equal to 0 minus dt, which is minus dt. Okay, and we have to change the limits also. Remember, when x equal to a equal to 2a minus t, that implies t equal to a. When x equal to 2a equal to 2a minus t, that implies t equal to 0. So therefore, how the given integral becomes? A to 2a f of x dx equal to integral a to 0 f of 2a minus t dt. Minus dt is there, no? That minus we can put in the outside of the integral. So this minus we can take inside and we can rewrite this like 0 to a, that minus will vanish. Using the second property I have written here, equal to f of 2a minus t dt, and applying the third one I have written here, change of variable doesn't affect the definite integral. So this can be written like f of 2a minus x dx. And look at the given thing, f of 2a minus x is equal to f of x. So this can be written like 0 to a f of x dx, right? So now I have marked the initially written equation like 1. So now I am going to put this finding in our equation 1. Therefore, equation 1 implies integral 0 to 2a f of x dx equal to integral 0 to a f of x dx. We have not done anything to the first integral, remember. The second integral's answer is here, integral 0 to a f of x dx. Now look at both of these integrals, they are the same, right? So we can write it like 2 times integral 0 to a f of x dx. So the correct answer is option D. Okay, so let us move on to the next sum. If matrix A equal to 1, 12, 4y, 6x, 5, 2x, 8x, 4, 6 is a symmetric matrix, then 2x plus y is, so let us understand the definition of symmetric matrix. A matrix is called a symmetric matrix if A transpose is equal to A, right? So what is A transpose for the given matrix A? We have to change the columns as rows and rows as columns, right? So interchanging of the rows and columns is called as A transpose, right? So 1, 6x, 8x and 12, 5, 4 and 4x, 2x, 6. So this is our A transpose, right? So since A transpose equal to A implies, let us write our A transpose 1, 6x, 8x, 12, 5, 4 and this is 4y actually, 4y, 2x, 6 equal to matrix A. Right, we will write the matrix A as it is 1, 12, 4y, 6x, 5, 2x, 8x, 4, 6. So when two matrices are equal, we know that their corresponding entries are equal, right? So what I am going to do is, I am going to compare the first row second entry of the LHS matrix and first row second entry of the RHS matrix, and that way we can find the value of x. The same way I am going to compare the first row third entry of the LHS matrix and first row third entry of the RHS matrix, and that way we can find the value of y. Okay, let us implement this idea. So 6x equal to 12, that will imply x equal to 12 by 6, which is 2, and 8x equal to 4y. Now we know the value of x, we can put that here. 8 into 2 equal to 4y, 16 equal to 4y, y equal to 16 by 4. So 4 is the value of y. Now we need to find out 2x plus y's value. So 2x plus y equal to 2 times 2 plus 4, right? X is 2 and y is 4. So this will be 4 plus 4, which is 8. So option D is the correct answer. Let's move on to the next sum. If y equal to sine inverse x minus 1 less than or equal to x less than or equal to 0, then the range of y is. So what do we mean here? Yeah, x can take minus 1 as the minimum most value and 0 as the maximum most value. So what will happen to y that time? That's what we need to tell here. So when x takes the value minus 1, y equal to sine inverse of minus 1, right? And if we recall our sine's values, sine 270 is the angle which takes the value minus 1, right? But the principal branch will not allow any value more than 90 degree, right? Because minus pi by 2 to plus pi by 2 is the value we have to look for our sine inverse function. So we can't take 270 here. So what we can say is sine of minus pi by 2 equal to minus sine pi by 2. Why? Because sine of minus x equal to minus sine x, since sine is an odd function. So that way we can write this minus 1 equal to minus sine pi by 2, and then we can carry forward. So this will be equal to sine inverse of minus 1 is the answer for sine pi by 2, and we cannot cancel sine inverse and sine when there is a negative sign in between them, right? So this negative sign we have to give inside the sine function. So that we can write like sine inverse of sine of minus pi by 2 because of this, right? Since sine is an odd function, that's why. So now sine inverse and sine will cancel each other. Minus pi by 2 is the value of y when x equal to minus 1, right? So when x takes the value 0, then y equal to sine inverse of 0, and you very well know that 0 is the answer for sine 0. So we can write it sine 0, and sine inverse and sine will cancel, we get 0 as the answer. So the range of y means what all the possible values that y can take, right? So that we can write range of y is the minimum most value that y can take is minus pi by 2. Maximum most value that y can take is 0. So the answer is minus pi by 2 comma 0 closed interval. Okay. See, open interval is also there in option A, but we have to choose closed interval because minus pi by 2 also y can take, because here minus 1 less than or equal to x is there. So when minus 1 less than x less than 0 is there, that time y cannot take the value minus pi by 2. That's when you have to select option A. But here x can take minus 1 as well, right? So y can take minus pi by 2 as well. So the closed interval minus pi by 2 comma 0 is the correct option. So option B is the correct answer. Let us solve sum number 6. If a line makes angles of 3 pi by 4, pi by 3 and theta with the positive directions of x, y and z axis respectively, then theta is. See, I have drawn the scenario. See, these are the axes x and y and z, and let this be the line L, the maroon colored one. Okay, and given that the line L is making these three angles, here I have marked alpha as the angle made between the line and the x-axis, beta as the angle made between the line and the y-axis, and gamma between the line and the z-axis respectively. Now let us see how to do this. Let alpha, beta and gamma be the angles made by the line with the positive directions of x, y and z axis respectively. So alpha is given to be 3 pi by 4 and beta is given to be pi by 3 and gamma is given to be theta. Now we know that the direction cosines of the lines are L, M and N, right? So let L, M and N be the direction cosines of the given line. So we know that L equal to cos alpha and M equal to cos beta and N equal to cos gamma. So in this particular sum, L equal to cos 3 pi by 4 and M equal to cos pi by 3 and N equal to cos theta, right? Also we know that L square plus M square plus N square equal to 1, right? So what does it mean? That implies cos square 3 pi by 4 plus cos square pi by 3 plus cos square theta equal to 1. Cos 3 pi by 4 is nothing but cos 135 degrees, whose value is equal to cos of 180 minus 45 degrees, which is equal to minus cos 45 degrees, which is equal to minus 1 by root 2. And cos pi by 3 is cos 60. Cos 60 is plus 1 by 2. Yeah. So now let us put those values here. So this is minus 1 by root 2 whole square plus 1 by 2 whole square plus cos square theta equal to 1. Okay. So that implies minus 1 by root 2 whole square will be 1 by 2 and 1 by 2 whole square will be 1 by 4 plus cos square theta equal to 1. That implies 1 by 2 plus 1 by 4 is 3 by 4, right? So 3 by 4 plus cos square theta equal to 1. That implies cos square theta equal to 1 minus 3 by 4, which is 1 by 4. So cos theta equal to square root of 1 by 4, which is plus or minus 1 by 2. So that means theta can take the value cos theta equal to plus 1 by 2 or minus 1 by 2. So when cos theta is plus 1 by 2, that time theta will be pi by 3. When cos theta equal to minus 1 by 2, that time theta will be 2 pi by 3. Okay. But here they have given pi by 3 only. We can't select this option. See, we should be given that pi by 3 or 2 pi by 3 as the option, but none of the options are correct here. Okay, so we can't select anything here. So there is some printing error in this question. So this should be the correct answer. And none of the options are correct here. Okay, so let us move on to the next sum. If E and F are two evens such that P of E greater than 0 and P of F is not equal to 1, then P of E bar given F bar is. See, usually we have by formula that P of A given B is equal to P of A intersection B divided by P of B, right? Applying this formula for P of E bar given F bar, we get probability of E bar intersection F bar divided by probability of F bar, right? By De Morgan's law, we know that A union B whole bar equal to A bar intersection B bar, right? So E bar intersection F bar will be E union F the whole bar. So this will be probability of E union F the whole bar divided by P of F bar. So we already know by the formula that probability of the complementary event of an event will be equal to 1 minus probability of that event, right? So this will be like E union F complements probability will be 1 minus P of E union F divided by P of F bar. We can leave this way because we already have one of the options matching with this format. So option D is the correct answer. Let us move on to the next sum. Which of the following can be both a symmetric and skew symmetric matrix? So let us recall the definitions for symmetric and skew symmetric matrix. Let A be the matrix which is symmetric as well as skew symmetric. Okay, A is symmetric implies A is equal to A transpose, right? Let us call this like our first equation, and A is skew symmetric implies minus A equal to A transpose, and we can write this like A equal to minus of A transpose, right? Let us call this like our second equation. Now let us see both the LHS of equations 1 and 2, both are A only, right? So we can add both of them. 1 plus 2 implies sum of both the LHS values will be A plus A, and the sum of both the RHS values will be A transpose plus of minus A transpose. That becomes 0, right? So that implies 2 times A equal to 0, that implies A equal to 0. 0 means the null matrix of the same order. Yeah, so option C is the correct answer. A should be a null matrix. Only a null matrix can be both symmetric and skew symmetric at the same time. Okay, let us move on to the next sum. The equation of a line parallel to the vector 3i plus j plus 2k and passing through the point 4 minus 3 comma 7 is, let us recall about the formula here. The equation of a line which is parallel to ai plus bj plus ck passing through the point x1 y1 z1 will be x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c, isn't it? Now let us use the given information and we will write the line which is obtained in this particular situation. Therefore, required lines equation is x minus, see 4 minus 3 7 is our passing through point. So this is our x1 y1 z1 and parallel to the vector 3i plus j plus 2k. So this we can take like ABCs. Okay. Now let us write the equation of the required line. X minus 4 divided by 3 equal to y minus of minus 3 divided by 1 equal to z minus 7 divided by 2 equal to some t. Okay. Why we are choosing t? Because here t is coming, so that's why. Now we can compare each and every fraction with the t and we will write the values of x, y, z here. So let's do that. The comparing first and the t value here, x minus 4 by 3 equal to t implies x minus 4 equal to 3t. That implies x equal to 3t plus 4, right? 3t plus 4. And let us take the second fraction and the t value. So y minus of minus 3 will be y plus 3, right? Y plus 3 by 1 equal to t implies y plus 3 equal to t. That implies y equal to t minus 3. Okay, and then the last fraction z minus 7 by 2 equal to t implies z minus 7 equal to 2t. That implies z equal to 2t plus 7. So the correct option is C here. Okay, let us move on to the next sum. Sum number 10. 4 friends Abhay, Bina, Chaya and Devesh were asked to simplify 4ab plus 3 times ab plus ba minus 4 times ba, where a and b are both matrices of order 2 by 2. It is known that a is not equal to b, not equal to I, and a inverse is not equal to b. So let us understand something here. We know that the product of two matrices is not commutative, right? So we cannot say that AB and BA both are equal, even though both AB and BA are defined, right? See, A is also 2 by 2 matrix, B is also 2 by 2 matrix, but AB also is a 2 by 2 matrix, BA is also 2 by 2 matrix, but their values won't match, right? So AB not equal to BA. So what we can do is 4 times AB plus 3 times AB plus BA minus 4 times BA can be written like 4 times AB plus 3 can be distributed inside. That can be done. 3 times AB plus 3 times BA minus 4 times BA. So we cannot combine AB and BA together, but BAs we can combine together, ABs we can combine together. So adding these two, we get 7 times AB, and plus 3BA minus 4BA will be minus 1BA, right? So the answer 7AB minus BA was given by Bina, right? So who answered it correctly? Bina answered it correctly. So option B is the correct answer. Okay, so let us move on to the next sum. Sum number 11. A cylindrical tank of radius 10 centimeter is being filled with sugar at the rate of 100 pi centimeter cube per second. The rate at which the height of the sugar inside the tank is increasing is, we have to find it out. So see, seeing this centimeter cube per second, we can easily understand that the rate of change of volume is given, right? So with respect to time, of course, second is given, right? So with respect to time, so what is given to us? Given dV divided by dt equal to 100 pi centimeter cube per second. This is a cylinder. So what is the volume of the cylinder? Volume of the cylinder equal to E, which is pi r square h, right? So r is the radius and h is the height of the cylinder, where r is given to be 10 centimeter and h is the height of the cylinder, which is unknown right now. Okay, rate at which the height of the sugar inside is increasing. So they are asking dH by dt. Okay, that is to be found. So what we are going to do is, we are going to find out dV by dH. Yeah, so V equal to pi r square h implies V equal to pi into r's value we know, right? So that we can put here. That is a constant here actually, because tank's radius cannot be changed, right? That is fixed. Only sugar keeps increasing in its height, right? So h is the variable quantity here. So pi into 10 square into h, that will be equal to 100 pi h. Okay, so dV by dH will be 100 and pi both are constant, and derivative of h with respect to h will be 1. right? So dv by dh is 100 pi. Now what I am going to do is, I am going to take dv by dt and I am going to apply chain rule here, which can be written like dv by dh into dh by dt, isn't it? We can do this, right? So that implies, see, dv by dt's answer we have already known. So 100 pi equal to, see, dv by dh also is 100 pi only, that we found just a while ago. So that is also 100 pi, right? And dh by dt we need to find out. That implies this we can take to the left side denominator. So 100 pi divided by 100 pi equal to dh by dt. That implies dh by dt equal to 1. So what about the unit? See, the radius is given with centimeter unit. So height is also considered this in the same unit, right? So 1 centimeter with respect to time only. So second is the times quantity. So 1 centimeter per second is the rate at which the height of the sugar is increasing. Okay. So we have to select option C. So let us move on to the next sum. Let P and Q be two unit vectors and alpha be the angle between them. Then P plus Q will be a unit vector for what value of alpha? Okay, let us apply the given condition. What is given to us? Given P and Q are unit vectors. What do you mean by unit vectors? Their length is 1, right? That implies length of vector P equal to 1 and magnitude, right? We call the length like magnitude. So magnitude of vector Q is also 1. Okay. Now I am going to find out P dot Q. Why unnecessarily P dot Q? Because the angle between the vectors is considered. So either we have to take dot product or the cross product to include the angle in it, right? Here I am going to use the dot product between the vectors. So P dot Q equal to magnitude of P into magnitude of Q into cos of the angle between them, right? So cos alpha. Okay. So now let us apply the values which we know right now. So this will be magnitude of P is 1, right? Magnitude of Q is also 1. So 1 into cos alpha, which is just a cos alpha. What do you mean by that? P dot Q's value is nothing but cos alpha. We will save this for our future purpose. Now let us continue further. Now I am going to find out P plus Q vectors lengths square. Why? Because we know by a formula that length of A square equal to A dot A. So that is the only formula which connects the magnitude of a vector to its dot product, right? So that's what we are going to use here. We will say that this is equal to P plus Q dot P plus Q, right? So this will be like P dot P plus Q plus Q dot P plus Q, right? Now again we have to apply distributive property here, which is equal to P dot P plus P dot Q plus Q dot P plus Q dot Q, right? So obviously you guys know that P dot P is nothing but length of P square, and P dot Q I am keeping as it is right now, and Q dot P also we can write like P dot Q. Why? Because dot product of vectors is commutative, so we can switch their places, nothing goes wrong, right? So Q dot Q will be length of Q square. Now since length of P is 1, length of P's whole square is 1 square, correct? So this is 1 square. Here these two P dot Q's we can add together, so we can write it like 2 times P dot Q, and this next one, this is also 1 square. Okay, so this becomes 1 plus 1 plus 2 times P dot Q. Okay, so this will be like 2 plus 2 times P dot Q. And if I call this like my equation 1, see what is the value of P dot Q? It is nothing but cos alpha, right? So I can write this like 2 plus 2 times cos alpha. Okay. And length of P plus Q. See what is given in the sum is P plus Q will be a unit vector. If you want P plus Q to be a unit vector, then I will write that here. Let P plus Q also be a unit vector. Okay, so obviously P plus Q is a unit vector, then its length is 1, right? So LHS we will have 1 square, right? So here 1 only we will get, right? Now let us continue further. This 2 we can take to the left side. So 1 minus 2 will be minus 1, right? 1 minus 2 equal to 2 cos alpha. That implies minus 1 equal to 2 cos alpha. That implies minus 1 by 2 equal to cos alpha will be obtained when alpha is 120 degree, right? So we know that cos 120 degree is equal to minus 1 by 2. So alpha equal to 120 degrees or 2 pi by 3 is the equivalent radian measure for 120 degree, right? So option D is the correct answer. Let us move on to the next sum. The line x equal to 1 plus 5 mu and y equal to minus 5 plus mu, z equal to minus 6 minus 3 mu passes through which of the following point? So this we have to write in the standard form of the line equation, then only we will correctly interpret the given information, right? So let us do that now. X equal to 1 plus 5 mu implies x minus 1 equal to 5 mu. That implies x minus 1 by 5 equal to mu, right? The same way let us do for the other value. Y equal to minus 5 plus mu. That implies y plus 5 equal to mu. That implies there is nothing in the denominator of y plus 5. That means we can put a 1, right? Because anything by 1 is the same. And let us take the z value now. Z equal to minus 6 minus 3 mu. That implies z plus 6 equal to minus 3 mu. That implies z plus 6 divided by minus 3 equal to mu. Therefore, what we can say here, x minus 1 by 5 equal to y plus 5 by 1 equal to z plus 6 by minus 3 equal to mu. Since all of them are equal to mu, we can write like this, right? So, now comparing with the general equation, x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c equal to mu. Yeah, where a, b, c's are the drs of the line and x1, y1, z1 is a point through which this line passes through, right? So compare this x1 and that value in our equation. Yeah, so we can write this like x minus 1 by 5 equal to this y plus 5 we can write like y minus of minus 5 by 1, and this z plus 6 also we can write like z minus of minus 6 by minus 3 equal to mu. Why are we writing like that? Because we want minus before x1, y1 and z1. So that's why we are adjusting our lines equation like this. So when we compare with this, we get x1 equal to 1 and y1 equal to minus 5 and z1 equal to minus 6. So the point is x1, y1, z1 is 1 minus 5 minus 6, which is given in option C. Okay, so let us move on to the next sum. If A denotes the set of continuous functions and B denotes the set of differentiable functions, then which of the following depicts the correct relation between set A and B? Okay, so see, A is the set of continuous functions and B is the set of all differentiable functions. One thing we have to understand here is every differentiable function is continuous, right? So without continuity, we can't differentiate the function, right? So if I am saying a function is differentiable, then it indirectly means that it is a continuous function, right? So we know that every differentiable function is continuous. So what do you mean by this? B is the set of differentiable functions and A is the set of continuous functions, right? So every differentiable function is a continuous function means B is a subset of A, right? But let us think about the other way. Are all continuous functions differentiable? No, right? Why? How can we say that? Because, for example, if we take the modulus function y equal to modulus x, this is a continuous function, no doubt about that. But we know that modulus x is not differentiable at x equal to 0, right? So we can't say that this is differentiable, okay? So this is one example that not all continuous functions are differentiable. So that's what we are going to say now. What we can conclude here, right? Every differentiable function is continuous means B is a subset of A, but A is not a subset of B, right? So what we have to select is A is the superset of B and B is a subset of A. That's what we have to select here, and this situation is given in option B. See, A is the outer set and B is the inner set. This is the correct situation. So option B is the correct answer. Let us move on to the next sum. The area of the shaded region, refer to the figure, represented by the curves y equal to x square. X lies between 0 and 2 and y axis is given by. See, one thing we have to understand clearly here is when they are asking you find the area of y equal to x square between the values x equal to 0 and x equal to 2, yeah, we have to do, when the limits for x is given 0 to 2, we have to do the integration with respect to x only, right? When dx is here, we have to put y here, yeah? But when we do 0 to 2 y dx, yeah, we will get the purple shaded region which I have marked here, okay? When you are going to find the area of the curve y equal to x square between the bounds x equal to 0 and x equal to 2 and the x-axis, you will get the purple shaded region, but that is not the thing they are asking here. So this is just a trap, okay? So clearly understand the situation. Here y equal to x square is given and the y-axis is taken as the reference. So we want to know the limits with respect to y. Okay, so y-axis is there, from which value of y to which value of y this curve is getting integrated. That's what we have to say. So y equal to a and y equal to b are the end values of the area zone. Then I have to put a dy here. When dy is here, I have to put x dy, right? That is how I have to find the area. So we are in the second format only because y's limit are going to be considered because y axis is taken for reference, okay? So how can we find when y's boundaries are not at all mentioned here? But we can find it. Like how? Let us see. When x takes its lowermost value 0, that time y equal to 0 square, which is also 0. Yeah. So when x takes its uppermost boundary 2, that time y is 2 square, which is 4. So the limits for y will be 0 to 4 right now. So from y equal to 0 to y equal to 4, we are going to integrate the x value with respect to dy. How can I write the value of x here? Yeah. So because everything is in terms of y, I have to write x in terms of y, right? So take the given curve y equal to x square, that implies x equal to, when I apply square root on both sides, I will get x equal to root of y, right? So this I can write like 0 to 4 root of y dy. This will give me the orange shaded region which I have marked here. That is the exact thing they are asking you. So you have to select option D. Okay, that is the correct answer. So let us move on to the next sum. Sum number 16. A factory produces two products X and Y. The profit earned by selling capital X and capital Y is represented by the objective function Z equal to 5x plus 7y, where X and Y are the number of units of X and Y respectively sold. Which of the following statement is correct? Okay, suppose there are two products, okay, one is X and one is Y, and how many units of X we are selling? X units of capital X product we are selling, and there will be some profit obtained from this, right? And same way, when the product Y is sold, Y units of product capital Y is sold, some profit will be earned from this transaction also. So when we write the objective function for both, we will add both the profits, right? So that is how we have to do this, right? Combined profit only we are going to do here. So the objective function maximizes the combined profit earned from selling capital X and capital Y is the correct answer. So option C is the correct answer. Okay, let us move on to the next sum. Sum number 17. If A and B are square matrices of order M such that A square minus B square equal to A minus B into A plus B, then which of the following is always correct? Yeah, let us take the given thing. A minus B into A plus B, I am going to start the process. This is like A into A plus B minus B into A plus B. Okay, so this becomes A into A plus A into B minus B into A minus B into B, right? So this is equal to, same like the distributive property only we will do for matrices, right? So A square plus AB minus BA minus B square is the answer for this. But look at what is given. A minus B into A plus B is equal to A square minus B square. Okay, so that implies A square minus B square equal to A square plus AB minus BA minus B square. Now let us take this A square and this B square to the LHS of the equation. So we get A square minus B square minus A square plus B square equal to AB minus B. So that implies, see, A square and minus A square will cancel each other. Minus B square and plus B square will cancel each other. So we get a null matrix as the answer in the LHS. So AB minus BA equal to null matrix. So that implies AB equal to null matrix plus BA, which is BA, right? So option B is the statement which is always correct. Okay, so let us move on to the next sum. If P and Q are respectively the order and degree of the differential equation d by dx of dy by dx the whole cube equal to 0, then P minus Q is. Okay, see, now this differential equation is not in the completed version. Okay, why? Because usually differential equations will be something like a power n into dy by dx power something plus a power n minus 1 into something like that, right? So d square y by dx square or a power n minus 1 into dy by dx plus etc. equal to something. Yeah, this is the format it is supposed to be. But here d by dx of dy by dx whole cube equal to 0 means what is d by dx of dy by dx whole cube? That is not completely done, right? So we have to do that before checking the order and degree of the equation. So let us take d by dx of dy by dx whole power 3 equal to 0. That implies, see, think about dy by dx as some t, okay, some t power 3. Then what is the differentiation of t power 3? It will be 3t square, right? Just like that, okay, for example. So the differentiation of dy by dx whole cube will be 3 into 3 dy by dx power 3 minus 1, and then we will apply the chain rule, right? So the innermost values also to be differentiated, right? So the differentiation of that will be d square y by dx square. Yeah, so differentiation of dy by dx is d square y by dx square. Yeah, so that this is equal to 0 on the other side. So that implies 3 into dy by dx power 2 into d square y by dx square equal to 0. Right now only this differential equation is in the correct format of the equation. Okay, now see what about order and degree? Order means the highest derivative. Yeah, order means the highest derivative done. So here dy by dx means differentiated once, d square y by dx square means differentiated twice. So the highest times it is differentiated is 2 times, right? So that implies order equal to 2, but here p is represented as the order of the differential equation. So this implies p equal to 2. Okay, the same way degree means power of the highest derivative. That implies what? D square y by dx square is the highest derived term, right? And what is the power of that? There is nothing in the power. That means 1 is the power of that term. So we should not tell 2 as the degree here because that is the power of the first derivative. Okay, but the order is 2. So that term's power only we have to tell. So degree is 1 here. So degree is 1 here, and degree of this equation is mentioned as q in the sum. So q equal to 1. Now we need to find out p minus q. So p minus q equal to p is 2 and q is 1. So 2 minus 1 is 1. So the correct answer is option B. Okay, let us move on to the assertion and reason based sum. Sum number 19. Assertion A is given like A equal to diag of 3, 5, 2 is a scalar matrix of order 3 by 3. Okay, one thing we have to understand is one diagonal matrix can be written in this way, right? So if they give you like this, what do you mean by this? So matrix A equal to diag of A11, A22, A33. I mean only the diagonal entries are given and there are these 3, right? So this is a matrix of order 3 by 3. So we can write this like A11, A22, A33 in the diagonal, and any diagonal matrix will have the non-diagonal entries as 0, right? So the rest of the entries will become 0 here, like this. If you want to call the same diagonal matrix as a scalar matrix, that is true only when A11, A22, A33 are all equal to each other, right? So any diagonal matrix is a scalar matrix when A11 equal to A22 equal to A33. Our given A is diagonal matrix 3, 5, 2. What do you mean by that? It is a 3 by 3 matrix which is 3, 0, 0, 0, 5, 0, 0, 0, 2. Are the diagonal entries same here? No, right? So in which A11 is not equal to A22 is not equal to A33. So we can't say A is a scalar matrix. A is just a diagonal matrix only, not a scalar matrix. So in assertion they are saying A is a scalar matrix only, right? Which is a false statement. Okay, now see the reason are, if a diagonal matrix has all non-zero elements equal, it is known as a scalar matrix. That is the definition for a scalar matrix, which is perfectly correct. Yeah, so reason is perfectly true, but the assertion is false. So when the assertion is false and the reason is true, we pick the option D as the correct answer, right? Let us see the next sum. Assertion A, every point of the feasible region of a linear programming problem is an optimal solution. Reason are, the optimal solution for a linear programming problem exists only at one or more corner point or points of the feasible region. The reason is perfectly correct because we know that, suppose let me draw one diagram for your understanding. If these are the lines given, okay, so this is the, suppose if this is the feasible region, okay, where is the optimal solution of this feasible region occur? See, there are four corner points, right? So there are four corner points here. So the optimal solution will be existing at one or more than one corner point of the feasible region. But here they are saying every point of the feasible region will give you optimal solution. That is not correct. Okay, so assertion is false here and reason is perfectly true. So when the R is reason is true and assertion is false, the correct answer is option D again in this sum also. Let us solve section B, very short answer type carrying 2 marks each. Sum 21 has two choices. Part A is, a vector A makes equal angles with all the three axes if the magnitude of the vector is 5 root 3 units, then find the vector A. Okay, suppose if we have the three axes like that and this is the vector, then this is alpha, this is also alpha and this is also alpha. Why? Because it makes equal angles with all the three axes. Let alpha be the angle made by the vector with all the three axes. Let L, M, N be the direction cosines of the given vector A. Let A vector equal to A1i plus A2j plus A3k, where A1, A2, A3 are the drs of the vector. Okay, so we know by a formula that L equal to A1 divided by root of A1 square plus A2 square plus A3 square, M equal to A2 divided by root of A1 square plus A2 square plus A3 square, N equal to A3 divided by root of A1 square plus A2 square plus A3 square. Also we know that L equal to cos alpha, M equal to cos alpha, N is also equal to cos alpha. That is given already, right? So also we know one thing, that L square plus M square plus N square equal to 1. Yeah, that is also another formula we have. That implies all of them are cos alpha. So cos square alpha plus cos square alpha plus cos square alpha equal to 1. That implies 3 cos square alpha equal to 1. That implies cos square alpha equal to 1 by 3. That implies cos alpha equal to plus or minus root of 1 by 3, which is plus or minus 1 by root 3. Also, magnitude of the vector is given as 5 root 3 units. Okay, so that we are going to use now. Given magnitude of vector A equal to 5 root 3 units. So what do we mean by that? Root of a1 square plus a2 square plus a3 square equal to 5 root 3 units. Right? Now we are going to take the values of L, M and we have written and kept. L equal to a1 by root of a1 square plus a2 square plus a3 square, which implies L is cos alpha, right? Cos alpha equal to a1 by root of this value is 5 root 3 and cos alpha's value is plus or minus 1 by root 3, right? That implies plus or minus 1 by root 3 equal to a1 by 5 root 3. So that implies plus or minus 5 root 3 divided by root 3 equal to a1, right? That implies a1 equal to plus or minus 5 because root 3 cancels. Okay, same way m equal to a2 divided by root of a1 square plus a2 square plus a3 square implies again cos alpha equal to a2 by 5 root 3. This also will imply a2 equal to plus or minus 5. Okay, similarly n equal to a3 divided by root of a1 square plus a2 square plus a3 square implies a3 is also equal to plus or minus 5. Therefore, vector A equal to, if we take all positive values, it will be 5i plus 5j plus 5k. If we take negative values, then it will be minus 5i minus 5j minus 5k. So, we can write it like A equal to plus or minus 5i plus 5j plus 5k, or we can take 5 common outside and we can write this way also. So this is the value of the vector. Okay, so let us move on to the next sum. The next option of the sum number 21. If alpha and beta are position vectors of 2 points P and Q respectively, then find the position vector of a point R in QP produced such that QR equal to 3 by 2 QP. So let us try to understand the situation. This is Q and this is P. It is produced to a point R and this ratio is satisfied. Okay. So QR equal to 3 by 2 QP implies QR divided by QP. This QP can go to the left side denominator. So this is equal to 3 by 2, right? That implies QR is to QP equal to 3 is to 2. What do you mean by that? So if this QR is 3 portions, then this QP is 2 portions. So what about RP? RP will be 1 portion then, right? Because then only we will get this together as 3 portions, right? So this we can write like RP is to RQ equal to 1 is to 3, right? So that is R divides PQ externally in the ratio 1 is to 3, right? So that's how we have to write. Hope you remember. So given is position vector of P is alpha bar and position vector of Q is beta bar. We have to write the point R's position vector like m times position vector of the second point, and n times the position vector of the first point divided by m minus n, where m is equal to 1 and n is equal to 3. That is what we have obtained, right? So that implies r vector will be 1 into beta, which is beta, and n is 3, so 3 alpha by 1 minus 3, which is beta minus 3 alpha by minus 2, right? Or we can take this minus to the numerator and we can write this like 3 alpha minus beta divided by positive 2. That is the position vector of the point R, right? So that's the end of the sum. Let us move on to the next sum. Sum number 22. Evaluate integral 0 to pi by 4 square root of 1 plus sine 2x dx. Sin x plus cos x whole square's value. Okay, we are randomly starting from something and you will know why we are doing this, right? So sin x plus cos x whole square, applying the identities, we will get sin square x plus cos square x plus 2 into sin x into cos x, right? That is the expansion of this. And we know that sin square plus cos square is 1. So this will be 1 plus 2 sin x cos x. And we know by the formula of sin 2x, 2 sin x cos x is equal to sin 2x, right? So this will be 1 plus sin 2x. So we are going to replace 1 plus sin 2x with sin x plus cos x whole square in the given integral. Okay, let us see what happens. Therefore, integral 0 to pi by 4 root of 1 plus sin 2x dx is equal to integral 0 to pi by 4 square root of sin x plus cos x the whole square dx. Okay, the whole purpose of doing this is just to get rid of the square root. Okay, now we have achieved that. How? Because whole square and square root will cancel each other. So we will simply get 0 to pi by 4 sin x plus cos x dx. Okay, now we can split this into sum of two integrals, right? Like integral 0 to pi by 4 sin x dx plus integral 0 to pi by 4 cos x dx. We know by the formula that integration of sin x is minus cos x and integration of cos x is sin x. So we can write this like minus cos x between the limits 0 to pi by 4, and this is sin x between the limits 0 to pi by 4. So this will be minus can be taken common and upper limit value minus lower limit value. So we get cos pi by 4 minus cos 0 here. The same way here also sin pi by 4 minus sin 0. And cos pi by 4 is cos 45 degree, right? Cos 45 degree is equal to 1 by root 2. Sin 45 degree is also 1 by root 2. And cos 0 is 1 and sin 0 is 0. So applying all the values required, we get minus 1 by root 2 minus cos 0 is 1 plus 1 by root 2 minus 0. Taking this minus inside, we get minus 1 by root 2 minus of minus 1 is plus 1 plus the second bracket is just 1 by root 2, right? And this minus 1 by root 2 and plus 1 by root 2 will cancel each other. We get answer equal to 1. Yeah, that's the final answer. Let's move on to the next sum. Sum number 23. Find the value of a for which f of x equal to sin x minus ax plus b is increasing on R. Always when they are asking about the increasing or decreasing nature of a function, we have to find the critical point, right? So that can be achieved by finding f dash of x, and we will discuss about the nature of f dash of x, and then we can find out in which zone it is increasing or decreasing. Let us take f of x equal to sin x minus ax plus b. So f dash of x will be sin's derivative is cos x minus ax derivatives. A is constant, keep it, x derivative is 1, b is also a constant, so its derivative is 0. So f dash of x is like cos x minus a. Okay, so when we put f dash of x equal to 0, that implies cos x minus a equal to 0, that implies a equal to cos x. Okay, a equal to cos x. So when the function will be increasing, when f dash of x is greater than or equal to 0, right? So f of x is increasing if f dash of x is greater than or equal to 0. That implies cos x minus a is greater than or equal to 0. Taking this a to the other side, we get cos x is greater than or equal to a. Right? Or we can write this like a less than or equal to cos x also. Okay, now if you know the nature of the cos function, yeah, the cos function will be like this, right? So it is a bounded function which always shuttles between -1 and +1, right? So the maximum most value that cos function can take is +1, and the minimum most value that cos function can take is -1, right? So a less than or equal to cos x is what we have obtained from the previous thing. Yeah, but we know that -1 less than or equal to cos x less than or equal to +1. Okay, if you want a to be below cos x, a should be below -1, right? Why? Because cos x's minimum most value is -1. Since this a is below cos x, it can be -1 or even below that, right? So that implies a is below -1 means what? A will belong to the interval -infinity comma -1. The -1 side is closed because a can take -1 as well, right? So -infinity comma -1, that is what we are going to take. If a belong to this interval, that is when the given f of x will be increasing function. Okay, so therefore f of x will be increasing if a belong to the interval -infinity comma -1. Okay, let us move on to the next sum. Sum number 24. If vector a and b are two non-collinear vectors, then find x such that alpha equal to x minus 2, a plus b and beta equal to 3 plus 2x times a minus 2b are collinear. They have given vector alpha equal to x minus 2 times vector a plus vector b. Okay, and another vector b beta is given like 3 plus 2x times vector a minus 2b. In this, vectors a and b are non-collinear vectors. Okay, so what we need to find is, in case if this alpha and beta are collinear, that happens for which value of x? Okay, that is what is asked here. When we call two vectors collinear, yeah, suppose if we have vector p and vector q, when will you say them as collinear vectors? Yeah, P equal to lambda times Q. Some scalar times Q, right? That is when you will call both the vectors are collinear, right? The same logic applies here also, right? So, alpha and beta are collinear. This is given already, okay? These two are collinear. That implies alpha equal to some lambda times beta. So, that implies x minus 2 times vector A plus vector B equal to lambda into 3 plus 2x times vector A minus 2 times vector B. If we multiply each and everything inside the right side with lambda, we will get this like 3 plus 2x into lambda times A vector minus 2 lambda times B vector. This side LHS will be the same thing. Yeah, so when we have one vector equal to another vector, their corresponding coefficients should be equal to each other, right? So that implies x minus 2 is equal to 3 plus 2x times lambda, and b's coefficient is 1 in the LHS. So 1 equal to b's coefficient in the other side is minus 2 lambda. So the second relation 1 equal to minus 2 lambda will help us find the value of lambda, which is 1 by minus 2. Yeah, that implies lambda is minus 1 by 2. And we are going to use this particular lambda in our first relation. That will help us find the value of x. Okay, let us continue. So x minus 2 equal to 3 plus 2x times lambda implies x minus 2 by 3 plus 2x equal to minus 1 by 2, because that is the answer of lambda we got, right? So when we cross multiply, we get 2 times x minus 2 equal to minus 1 time 3 plus 2x. So multiplying, we get 2x minus 4 equal to minus 3 minus 2x. Taking all the x values together and all the numbers together, we get 2x plus 2x equal to minus 3 plus 4. So we get 4x equal to 1. So that gives the value of x as 1 by 4. So conclude the sum. Alpha and beta will be collinear if x equal to 1 by 4. Yeah, let us move on to the next sum. Sum 25 has two choices. The first one is, if x equal to e to the power x by y, then prove that dy by dx equal to x minus y by x log x. Okay, so what is given to us? Given x equal to e to the power x divided by y. One thing we have to understand is, when the variables are in the power of e, the differentiation will become very difficult. So we can avoid this by taking log on both sides, right? So by applying log on both sides, we get log x equal to, log to the base e. Okay, so log to the base e equal to log e to the power x by y to the base e, right? So we usually won't write the base. Okay, if the base is not written, that means the base is to the value e. So that implies log x equal to, when this e and this base are equal to each other, both of them will cancel. X by y will get released from this, right? So that is the purpose of doing this, right? So this implies we can cross multiply this y to the left side. So we have y log x equal to x. So now we are perfectly ready for the differentiation. Okay, on differentiating with respect to x, y is a variable, log x is also variable only. So UV method we have to apply. So keeping y as it is, differentiation of log x we will do, and keeping log x as it is, differentiation of y we will do, and on the other side differentiation of x we will do. Okay, so that implies y into differentiation of log x will be 1 by x, right? Plus log x into differentiation of y will be dy by dx only. On the other side we have d by dx of x, right? So that is 1. So this implies y by x plus log x into dy by dx equal to 1. We need to find out the value of dy by dx. So keeping dy by dx related term in the LHS, sending this y by x term to the right side, we have log x into dy by dx equal to 1 minus y by x. And we can take x as an LCM here. So this is x minus y by x. Okay. So that implies log x into dy by dx equal to x minus y by x. And taking this log x to the other side, we have dy by dx equal to x minus y by x into this log x also joins the denominator of the other side, right? So we will get x minus y by x log x. That is what they are asking us to prove. So hence proved. That's the end of the sum. Let's move on to the other choice of the sum. If f of x equal to 2x minus 3 when x lies between minus 3 and minus 2, and f of x equal to x plus 1 when x is lying between minus 2 and 0. Check the differentiability of f of x at the point x equal to minus 2. We have to find the left side derivative of f of x, and we have to find the right side derivative of f of x both at the point x equal to minus 2, right? I mean L f dash of minus 2 and R f dash of minus 2, we have to find out. They should be equal to each other. Then only we can confirm f of x is differentiable at the point, right? L f dash of a will be equal to limit h tends to 0 f of a minus h minus f of a divided by minus h. Okay, and R f dash of a will be equal to limit h tends to 0 f of a plus h minus f of a divided by plus h. Correct? Hope you remember. Now we are going to take a equal to minus 2 and execute this. Obviously a minus h will be below a and a plus h will be above a. If we take x a equal to minus 2 here, then minus 2 minus h will be below minus 2. That time we have to take f of x equal to 2x minus 3. Why? Because when x is below minus 2, that is the value of f of x, right? So also minus 2 plus h is above minus 2. That time f of x will be x plus 1. Now let us do left side f dash of minus 2, which will be limit h tends to 0 f of a is minus 2, right? Minus 2 minus h minus f of minus 2 divided by minus h, right? So f of minus 2 minus h will be 2 into minus 2 minus h minus 3. Why? Because x can be replaced with minus 2 minus h here. That's how we got it. So this is equal to 2 into minus 2 is minus 4. 2 into minus h is minus 2h, and there is a minus 3. And this can be written like minus 7 minus 2h. So this is what our f of minus 2 minus h's value. And the same way f of minus 2 plus h's value will be equal to minus 2 plus h plus 1, replacing x with minus 2 plus h. So this will be minus 2 plus h plus 1. This is minus 1 plus h. Okay, these are the values we are going to take here. So let us see what happens. Limit h tends to 0. F of minus 2 minus h is Just now we found it minus 7 minus 2h minus what is f of minus 2? So f of minus 2 will be found from 2x minus 3 function only. So 2 into minus 2 minus 3 only. This will be minus 4 minus 3 which is minus 7. Yeah. So f of minus 2 is minus 7. So here minus of minus 7 divided by minus h. Okay. And continue further. This is equal to limit h tends to 0 minus 7. Minus of minus 7 will be plus 7 divided by minus h. And this will be limit h tends to 0. This minus 7 and plus 7 will cancel. We get minus 2h by minus h. And both these negative signs will cancel and h also will cancel. So we will end up having just a 2 here, whose answer is 2 only because limit of a constant is the same constant. So we got this answer for the left side derivative of minus 2. Same way we have to do for the right side derivative. So r f dash of minus 2 equal to limit h tends to 0 f of minus 2 plus h minus f of minus 2 by h. Just for our reference, I am rewriting the formula here. So this is limit h tends to 0. So this is minus 1 plus h minus f of minus 2 is minus 7 divided by h. Okay, continuing further, this is equal to limit h tends to 0 minus 1 plus h plus 7 divided by h. Okay, so this will be limit h tends to 0 6 plus h divided by h. So when we put h tends to 0, right, 6 plus 0 by 0 becomes indeterminate form. We can try to split this like 6 by h plus limit h tends to 0 h by h. Yeah. So this will be limit h tends to 0 6 by h plus this is just a 1, right? H and h cancel. Limit h tends to 0 of 1 is 1 only. But this limit of 6 by h is undefined. Why? Because 6 by 0 it becomes, which is undefined. So this becomes undefined. R does not exist. Okay, so now let us see the situation. The left derivative is existing, but the right derivative at minus 2 does not exist. If right derivative exists, then only we can compare whether left derivative and the right derivative are coming same or different, right? When the right derivative doesn't even exist, then how can we compare that, right? So that means the function is not differentiable. Okay, so that is our conclusion. Therefore, L f dash of minus 2 cannot be said equal to R f dash of minus 2. Therefore, f of x is not differentiable at x equal to minus 2. That's the conclusion here. Let us solve section C, short answer type carrying 3 marks each. Sum 26 has 2 choices. Number 1 is solve the differential equation 2 into y plus 3 minus xy into dy by dx equal to 0 given y of 1 equal to minus 2. So, first of all, before solving the differential equation, we have to identify which type of differential equation is given, right? So we have seen many differential equation types. The first one is variable separable and the second one is homogeneous equations. Okay, and the third one is linear differential equations. By seeing itself, we can very well say that this is not of the homogeneous type, right? Why? Because this term has degree 1 and this term has degree 2. X into y has degree 2, right? So we can't say this is homogeneous type. So this one is ruled out, right? So we have the other two types, and we cannot say this is linear equations. Okay, why? I'll show you how. See, if I take dy by dx related term on the other side, we will get 2 times y plus 3 equal to xy into dy by dx. And when this xy goes to the other side denominator, we have 2 times y plus 3 by xy equal to dy by dx. And if we write dy by dx equal to y 2y plus 6 divided by xy, this we can split like 2y by xy plus 6 by xy, right? This we can cancel. Okay, so the term which has both x and y should go to the other side, but if we take it to the other side, it will be something like this. Okay, so we should have dy by dx plus py equal to q, where p and q are functions of x are constants, right? But if you notice here, we can split this like minus 6 by x into 1 by 1 y only, right? We want p into y. So if we had minus 6 by x into y, then this could have been done using linear differential equations. But it is not of that type, so we can't take linear types also. So the only option left is variable separable only. So we are going to try with the variable separable method. So for doing the variable separable method, we have to separate out y related terms in one side of the equation and x related terms in other side of the equation, right? So let us do that. 2 into y plus 3 equal to xy into dy by dx. That step is the same. I am planning to take this dx to the other side, cross multiply dx to the other side. So 2 into y plus 3 into dx equal to xy dy. So this x has to go to the left side and this y plus 3 has to go to the right side. So we have 2 into dx divided by x equal to y by y plus 3 into dy. Okay, so we have separated the variables to both the sides. Now we can apply integration on both sides, right? That implies 2 times integral dx by x equal to integral y divided by y plus 3 dy. Let us consider integral y by y plus 3 dy, which is on the right hand side of equation 1. Now y by y plus 3, we are going to add a 3 and subtracting a 3, which doesn't have any impact, right? Divided by y plus 3. This can be split into two ratios like y plus 3 divided by y plus 3 minus 3 by y plus 3, which is nothing but 1 minus 3 by y plus 3. Okay, so therefore integral of y by y plus 3 dy equal to integral of 1 minus 3 by y plus 3 dy. Okay, this will become integral 1 into dy is dy minus 3 into integral 1 by y plus 3 dy. Because 3 is a constant, we can take it outside. And this will become y minus 3 into log of y plus 3, right? Because if you put y plus 3 equal to t, then dy becomes dt. So integral of 1 by y plus 3 dy will be integral dt by t, which is nothing but log t, and replacing t with its original value, we will get log of y plus 3 here. So this is the answer for the RHS. Okay, now let us go to the equation 1. Therefore 1 implies 2 into integral of dx by x is log x equal to, the answer for our RHS will be y minus 3 log of y plus 3. Okay, to the side in which x lies, right? So we will add the c to the LHS where x term lies. So this is our answer for the given differential equation, but we are not completely done. Why? Because given y of 1 equal to minus 2 means y of 1 equal to minus 2 implies when x equal to 1, y equal to minus 2. If they give something like that, no, this is a point on the curve, right? If they give a point lying on the curve, we have to find the particular solution of the differential equation. So here we have found the general solution. Now we need to find the particular solution of the above equation. Okay. Therefore, 2 log x plus c equal to y minus 3 log of y plus 3 when x equal to 1, y equal to minus 2. We are going to put that here. This implies 2 into log 1 plus c equal to minus 2 because y is minus 2 minus 3 times log of minus 2 plus 3. And this will be, we know that log of 1 equal to 0. So this will be 2 into 0 plus c equal to minus 2 minus 3 into log 1. That implies 0 plus c is c only, minus 2 minus 3 into log 1 is again 0. That implies c equal to minus 2. Okay. Therefore, the required particular solution is y minus 3 log modulus y plus 3 equal to 2 log x minus 2. Okay, that is the final answer. Let us go to the next sum. Solve the following differential equation: 1 plus x square into dy by dx plus 2xy equal to 4x square. Let us try to isolate dy by dx and see what type of equation we have. So divide by 1 plus x square throughout. 1 plus x square into dy by dx divided by 1 plus x square plus 2xy divided by 1 plus x square equal to 4x square by 1 plus x square. So that implies these two 1 plus x squares will cancel each other. Dy by dx plus 2xy by 1 plus x square equal to 4x square by 1 plus x square. Okay. Now this can be written like dy by dx plus 2x by 1 plus x square into y equal to 4x square by 1 plus x square. And by seeing itself, we can say that this equation is of the form dy by dx plus py equal to q. So, where p equal to 2x by 1 plus x square and q is equal to 4x square divided by 1 plus x square. So, this is the linear differential equation, right? So, we need to find the integrating factor. So, integrating factor equal to e power integral p dx, right? So, that is if equal to e to the power integral 2x by 1 plus x square dx. Now consider the integral which is on the power of e. Okay, consider integral 2x by 1 plus x square dx. How can we solve this? We have to use the substitution method, right? So, putting 1 plus x square equal to t, we get 0 plus 2x into dx equal to dt. That implies 2x dx equal to dt, right? Therefore, integral 2x by 1 plus x square dx becomes dt divided by t, whose answer is log modulus t, which is log modulus of 1 plus x square. See, 1 plus x square can never become negative, right? When you are afraid of getting a negative term, that is when you have to put a modulus, because log will never accept any value which is negative, right? But x square plus 1 can never become negative, so we need not put the modulus here. Just a bracket is enough. Yeah, because it is going to be positive always. That's why. Now what will happen to the integrating factor? We need to work out. So integrating factor equal to e power integral 2x by 1 plus x square dx is now equal to e power log of 1 plus x square, right? So now we know that when e to the power log is there, both of them will cancel each other. 1 plus x square will get released, right? So that will come out. So that is our integrating factor's final value. Now let us write the solution, right? Final solution. Therefore, required solution is y into integrating factor equal to integral q into integrating factor times dx, right? So now let us solve this. That implies y into integrating factor is 1 plus x square equal to integral q's value is 4x square by 1 plus x square, right? Into integrating factor is also 1 plus x square into dx. Okay, now what happens? This both 1 plus x squares will cancel each other. So we get y into 1 plus x square equal to integral 4x square dx. Okay, let us continue further. That implies y into 1 plus x square equal to 4 into integration of x square dx will be x cube divided by 3 plus constant of integration c. Okay, so that implies y into 1 plus x square equal to 4x cube by 3 plus c, or we can write this like y equal to 4x cube by 3 into 1 plus x square plus c by 1 plus x square. How did we get this? By dividing with 1 plus x square throughout, we can write like this, right? This is the required general solution of the given differential equation. Okay, that's the end of the sum. Let us move on to the next sum. Let R be a relation defined over n, where n is the set of natural numbers defined as m related to n if and only if m is a multiple of n, where m and n are integers. Find whether R is reflexive, symmetric and transitive or not. So we have to check the properties, right? Okay, given R equal to the ordered pair m comma n, where m is a multiple of n, where m and n are natural numbers. Let us check whether the reflexive property is getting satisfied or not. Let A belong to the set of natural number. We are taking one random number from the natural number set. We know that A is a multiple of A, isn't it? Like 2 is a multiple of 2, 5 is a multiple of 5, 6 is a multiple of 6, right? So like that. Any number is a multiple of itself, right? So A is a multiple of A. That implies I can write A comma A belong to R, because the first number should be a multiple of the second number, which is always true, right? So A comma A belong to R for every A belong to the natural number set. Okay, so that implies R is reflexive. So the reflexive property is getting satisfied here. Okay, now let us go to the symmetric property. See, when I have m comma n belonging to R, I have to prove that n comma m belong to R, right? That is when I can call R as a symmetric relation, right? But think about it. If I have the multiple in the first position and its divisor or factor in the second position, if I swap their positions, it won't work out, right? I cannot say the factor is a multiple of the original number, right? For example, if I have 8 comma 2 belong to R, is it possible? Yes, of course, because 8 is a multiple of 2 only, so it is always possible. But if I reverse their position, this will never be in R. Why? Because 2 is not a multiple of 8. It's a factor of 8, right? So I can't have it always true. So symmetric property is not satisfied in this relation. Okay. So whenever there is a condition not satisfied, we have to give a counter example, right? So that is what we are going to do now. Let us take 8 comma 2. Clearly 8 comma 2 belong to R because 8 is a multiple of 2, right? But 2 comma 8 does not belong to R because 2 is not a multiple of 8, right? So therefore A comma B belong to R implies B comma A does not belong to R. So we cannot call R as a symmetric relation, right? Therefore R is not symmetric. Okay, let us think about transitivity property. For that we need to take two pairs, right? Let A comma B belong to R and B comma C belong to R. So we are taking two ordered pairs from the relation R. That implies what? A is a multiple of B and in the next ordered pair we can say B is a multiple of C. Okay, so A is a multiple of B implies B can divide A, right? I can write A equal to some P times B. B, that is when B will divide A, right? Same way, if I call B is a multiple of C, that means B can be written as a product of some number with C. So Q times C I can say. Okay, so now A equal to PB and B equal to QC implies A equal to P into, I can replace B with B's value now, QC. Okay, that implies A equal to PQ into C. So A is a multiple of C. Some number into C is giving us A. That implies A is a multiple of C. Correct? So whenever A is a multiple of C, I can say A comma C belong to R. Right? See here, we have taken A comma B and B comma C from R and they are giving A comma C also in R. That implies R is transitive. Right? R is a transitive relation. So, reflexivity and transitivity are obeyed by R, but symmetric property is not obeyed by R. Okay, that is what they are asking us to check and we are done. So let us move on to the next sum. Sum number 28. Solve the following linear programming problem graphically. Minimize z equal to x minus 5y subject to the constraints x minus y greater than or equal to 0, minus x plus 2y greater than or equal to 2, x greater than or equal to 3, y less than or equal to 4 and y greater than or equal to 0. So now let us consider the lines which we need to draw, right? So from the first inequation, we have to draw the line x minus y equal to 0, right? I mean x equal to y. That line we have to draw. So take any random point on the line and we can be able to draw the line. For example, If x equal to 3, then y is also equal to 3. Same way, if x equal to 4, then y is also equal to 4. So we are taking 3 comma 3 and 4 comma 4 as the points which we need to plot. Okay, I am calling this point like P and this point like Q. Okay, now let us consider the next line. Without the inequation, we have to write it like minus x plus 2y equal to 2. Okay, so if x equal to 0, we will get minus 0 plus 2y equal to 2. That means 2y equal to 2, right? So that will give you y equal to 2 by 2, which is 1. So the point will be 0 comma 1. So if I take y equal to 0, then I'll get minus x plus 0 equal to 2, or I can say minus x equal to 2. That implies x equal to minus 2. So the point will be minus 2 comma 0. I am going to call this point like R and this point like S. Okay. Let us take the next inequation, x greater than or equal to 3, and the line we need to draw for this is x equal to 3, right? And this is very easy. Okay, any line, any vertical line passing through 3 is the required line, and the next line what we are going to draw for the next inequation will be y equal to 4. This is also very easy. Any horizontal line passing through 4 is what we need. So we need to plot all these points in the graph sheet. Let's see. This is the point we have taken like our point P, 3 comma 3, and this is the point we have taken. Okay, I am going to call this 4 comma 4 point like C. Okay, then this is the point C, which is 4 comma 4. Okay, and for the next line we got R 0 comma 1 and S minus 2 comma 0. So R 0 comma 1 is this point. Okay, R 0 comma 1, and S minus 2 comma 0 is this point. Okay, so and this point is 3 comma 0, and this point is 0 comma 4. Okay, now for the line x equal to y, we have taken points P and C, and the red line is the required line, right? And for the next line minus x plus 2y equal to 2, we have taken R01 and S minus 2 comma 0, and we have plotted those 2 points, and then we have joined them with the blue colored line. Okay, and for the line x equal to 3, this green colored line is the line which passes through x equal to 3, right? So that is the required line for that. And for the line y equal to 4, this purple line is the required line, the horizontal line, right? So all the lines we have drawn basically. Now we have to find out the feasible region. Okay, so let us see the inequations given to us originally, and then let us see which way it goes. Okay, so for the first inequation, they have given x minus y greater than or equal to 0. That implies x greater than or equal to y. So let us check which region obeys this condition. So for example, if I consider this point, this is 5 comma 2, right? So if I apply this point here, can I say 5 greater than 2? Of course, right? Yeah. So this point satisfies the inequation x minus y greater than or equal to 0. So that means the region below the red line, okay, that is our required zone, right? That is the required zone. So I mean this region we have to mark. Yeah. Okay. Now let us consider the next inequation. The next inequation given is minus x plus 2y greater than or equal to 2. Okay, see, that is the blue colored line, right? So origin is not sitting on the line, so we can check with the origin. Apply origin and check what happens. Okay, so when I put origin there 0 comma 0, I will get minus 0 plus 2 into 0 greater than or equal to 2. That means 0 plus 0 is 0 only. 0 greater than or equal to 2, which is false, right? So what do you mean by that? The side which contains origin is not going to be the required region, right? So we have to choose the opposite side of the origin side, right? 0, 0 side is not the required zone, so we will choose the other way. Okay, and the same way the next inequation is x greater than or equal to 3. So if I take any point from the left side of the green line or the right side of the green line, I have to test like that, right? Suppose if I take this point, okay, this is 2 comma 1. Okay, so can I say x greater than or equal to 3? X value is 2, right? So 2 greater than or equal to 3 is wrong, right? So I cannot choose this region, right? So the left side of green line is not the required region which I have to choose. So which region I will choose now? I have to choose the other side, right? Which side? This side. The right side of the green line, right? And then the same way, the next inequation says y less than or equal to 4. That means if I take this point, for example, the point which lies above the purple line, this point is actually 1 comma 5, right? So if I take this particular point and if I check here, y value is 5, right? So 5 less than or equal to 4 is not true, false, right? So I cannot choose the region which is lying above the purple line. So which one is the feasible region for us now? I have to select the region which is below the purple line, this region, right? So whatever we have discussed so far, I have put those with the arrows here. And see, we have to satisfy all the directions which the arrows are pointing, right? So I have to choose a region which is lying to the right side of the green line, below the purple line, and below the red line, and above the blue line. So this yellow shaded region is the region which satisfies all the given conditions, right? So that's why I have shaded this region, and I have got 4 corner points, right? Because it is a quadrilateral, a 4-sided figure. So there are 4 corner points for this region. So I am calling them like A, B, C, D. Okay, and we have to find the value of the objective function given at these corner points and see which point gives us the minimum value for the objective function, because we need to minimize the objective function. Let's see what we have to do. I have drawn a table. Okay, so we need to take the corner points here and the value of z here. Now let us look at the points obtained here, okay, and let us try to mark them down. Okay, what are the points obtained? Okay, let's see. A is having x value 3 and y value is not so clear, right? Because it is in between 2 and 3. We want to understand what that point is clearly. Okay, so for that A point lies on the intersection of the blue line and the green line. Okay, so the green line is x equal to 3 and the blue line is minus x plus 2y equal to 2. Okay, so this point A lies on the intersection of the lines, right? So I have to solve these two equations. Okay, this is done by substitution method. I am going to replace this x with a 3 to get the value of y here. So I will get minus 3 because minus x I want, plus 2y equal to 2. So 2y equal to 2, minus 3 goes to the other side, it becomes plus 3, total is 5. So y equal to 5 by 2, which is 2.5. See this A point? This is exactly midway between 2 and 3, right? So it is 2.5. So A point is 3, 2.5. What about point B? Point B's x value is 6 and y value is 4. So this point is 6, 4. And C is already marked point, right? We have already marked this 4, 4. And D point is also marked already 3, 3. So these are the points I have marked. So let us go to the table and write the corner points we have obtained. Point A is 3, 2.5 and point B is 6, 4 and point C is 4, 4 and point D is 3, 3. And we need to find the value of z in each of these points, right? So let us do the calculations here. Z equal to x minus 5y. When 3, 2.5 we are going to put in this, we will get 3 minus 5 into 2.5. Yeah, z equal to 3 minus 5 into 2.5, which will be 3 minus, so 3 minus 12.5. This will be minus 9.5. Okay, so here we can write minus 9.5 as the value. Okay, now let us do for the next point here. So when I put 6, 4, z equal to 6 minus 5 into 4, which is 6 minus 20, which is minus 14, right? So when I put 4, 4, z becomes 4 minus 5 into 4, which is 4 minus 20, which is minus 16. And when I put 3, 3, z becomes 3 minus 5 into 3, which is 3 minus 15, which is minus 12. So something like this. Okay. So the minimum most value among all these will be this one, right? Minus 16. The minimum most value is minus 16. So where is it attained? That value is attained at C 4, 4. Let us write the conclusion. The minimum value of Z is minus 16 and it is attained at the point 4, 4. Yeah, so that is the end of this sum. Let us move on to the next. Sum number 29 has two choices. The first one is y equal to log of root x plus 1 by root x whole square. Then show that x into x plus 1 whole square y2 plus x plus 1 whole square into y1 equal to 2. Okay, and of course you guys know y2 means d square y by dx square and y1 means dy by dx. Correct? So, right, so y equal to log of root x plus 1 by root x whole square. If we try to differentiate straight away with this format, it will be very difficult to proceed further. So we are going to do some simplification before we do the differentiation. So first thing we can try is taking root x as the LCM. So here this root x has to be multiplied by root x. It will be root x into root x, which is x plus 1 by root x. There is a whole square also. And now what we can do is this whole square we can give to both numerator and the denominator. So we get x plus 1 whole square divided by root x whole square, right? And this can be written like log of x plus 1 whole square by root x square will be just x only, right? So this is the value we are getting. Let us continue further. That will give you y equal to log of x plus 1 square minus log x. How can we say this? Because log of a by b can be written like log A minus log B, right? So that's how it is, right? So we can write like this way. And you know that log of a power m to the base b can be written like m into log a to the base b, right? So this power will go to the logs front, right? So this will be like 2 times log of x plus 1 minus log x. So this is the simplification that is ever possible. Yeah, now we can try to differentiate. Okay, so let us try differentiating this. Dy by dx equal to 2 by differentiation of log of x plus 1 will be 1 by x plus 1. So 2 into 1 by x plus 1 will be 2 by x plus 1 minus log x's derivative is 1 by x. Now we have to take x into x plus 1 as the LCM here. So this will become 2x minus 1 into x plus 1 is x plus 1 only. And this can be simplified further like 2x minus x minus 1 divided by x into x plus 1. And 2x minus 1x will be 1x. So x minus 1 by x into x plus 1 is the value of dy by dx. Now we are going to take this x plus 1 term to the left side. Okay, I mean x plus 1 into dy by dx equal to x minus 1 by x. This x we didn't take to the left side, right? It is staying on the right side only. So this way we are doing this, and this can be further simplified like 1 minus 1 by x. Okay, now we are going for the next derivative of this. Okay, let us continue. So let us try to differentiate once again on differentiating again with respect to x. So we are getting UV method we have to apply for the left side, right? Because x plus 1 and dy by dx both are variables. So keeping x plus 1 idle, derivative of dy by dx will be d square y by dx square, and keeping dy by dx idle, derivative of x plus 1 will be simply 1 only, right? The other side's derivative we have to do. Once derivative is 0 minus 1 by x's derivative is minus 1 by x square, right? So that implies x plus 1 into d square y by dx square plus dy by dx equal to minus of minus 1 by x square will be just 1 by x square. Okay, and we are going to multiply with x into x plus 1 throughout. Why? Because in the proof we are having x times x plus 1 whole square into second derivative, but here we are having just x plus 1 into second derivative. So to match with the proof's pattern, we have to multiply by x into x plus 1 throughout. Let's see what happens. So x into x plus 1 into the LHS equal to x into x plus 1 into RHS. Okay, let us continue further. This implies x into x plus 1 into x plus 1 into d square y by dx square will give you x into x plus 1 whole square into d square y by dx square plus x into x plus 1 into dy by dx equal to this x and one of the x can cancel here. That will give us x plus 1 by x. Further we get that implies x into x plus 1 whole square into d square y by dx square plus x into x plus 1 into dy by dx equal to 1 plus 1 by x, because I can split this like x by x plus 1 by x. So that's what we are getting here. Now look at this one. I will highlight here. Look at this term. This I am going to rewrite like taking 1 by x to the left side and x plus 1 into dy by dx to the right side. I can write this way, right? Yeah. So this value I am going to apply for this 1 by x. Okay. And let's see how this equation becomes. So that implies x into x plus 1 whole square into d square y by dx square plus x into x plus 1 into dy by dx equal to the RHS for this is 1 plus, replacing 1 by x with its value, I can write that like 1 minus x plus 1 into dy by dx. Correct? So that will become, when I add them, I will get 1 plus 1 minus. So I will get 2 minus x plus 1 into dy by dx. Taking this minus of x plus 1 dy by dx to the LHS, we will have x into x plus 1 whole square into d square y by dx square plus x into x plus 1 dy. We can multiply this, right? X square plus x into dy by dx, right? That way we can write x square plus x into dy by dx. And this minus of x plus 1 dy by dx goes to the left side. So it becomes plus x plus 1 into dy by dx equal to 2. So now let us see what happens. X into x plus 1 whole square into d square y by dx square. There is no change in that term. Now see the next term. Okay, both the terms are dy by dx, right? So I can take dy by dx common from them and combine their coefficients, right? So that will be like x square plus x in the second term and x plus 1 in the third term. So we have to just add all of them together. That side we have a 2. And see this bracket thing, this is x square plus 2x plus 1, right? This is the expansion of x plus 1 whole square, correct? So that implies x into x plus 1 whole square into d square y by dx square plus x plus 1 whole square into dy by dx equal to 2. So if we want to put y1, y2 replacing this, we will have x into x plus 1 whole square y2 plus x plus 1 whole square into y1 equal to 2. That's what we need to prove there. So hence proved. Okay, let's move on to the next sum. The next option of this sum. If x into root of 1 plus y plus y into root of 1 plus x equal to 0, x lies between minus 1 and plus 1 and x is not equal to y, then prove that dy by dx equal to minus 1 by 1 plus x square. Okay, so let us take the given thing. Given x into root of 1 plus y into root of 1 plus x equal to 0. Okay, that implies x into root of 1 plus y equal to, taking this term to the other side, we have minus y into root of 1 plus x. On squaring both sides, we will have x into root of 1 plus y whole square equal to minus y into root of 1 plus x whole square. So that implies x square into 1 plus y equal to y square into 1 plus x. Now this implies x square plus x square y equal to y square plus y square x. Okay, that implies taking these two terms to the LHS, we get x square plus x square y minus y square x equal to 0. Okay. Now we are going to combine these two terms together and combine these two terms together. Let us rearrange the terms. This is x square minus y square plus x square y minus y square x equal to 0. I am not going to do anything with the first two terms right now, and in the next two terms I am going to take xy common. Okay, we will get x minus y, right, equal to 0. Now this one x square minus y square we are going to combine together, and this looks like an identity, right? So we can split using the identity, which can be written like x plus y into x minus y plus xy into x minus y equal to 0. That implies we can take this term common, and combining rest of the terms together we get x plus y plus xy equal to 0. Okay, so product of two items equal to 0 means either the first item equal to 0 or the second item equal to 0, right? But if we take the first item equal to 0 in case, we will get x equal to y. But look at the given thing, x is not equal to y, right? So this is not possible. Not possible. Okay. So we have to go with the next thing only. Okay. So here you have to say, but x is not equal to y. Therefore, this thing we can take. Okay, and what we need to do, dy by dx we need to find out, right? For finding dy by dx, all the y related thing we have to keep in the left side, and we have to rewrite the equation, which is easy for differentiation purpose, right? So I am going to keep y plus xy term in the LHS, and this x I am going to take to the other side, which becomes minus x after going there, and I have to take y common from both the terms here. So y into 1 plus x equal to minus x. So y equal to minus x by 1 plus x. Okay, now this value is ready for differentiation. Now we are going to do the differentiation for this using u by v method. Okay, and what's the formula we are going to apply? D by dx of u by v equal to v u dash minus u v dash by v square, right? So this is our u and this is our v, right? So dy by dx is equal to v into u dash means v is 1 plus x, and the derivative of minus x will be minus 1. Okay, minus u into v dash. U is minus x already. V dash means derivative of 1 plus x. Yeah, 1 plus x's derivative is 1 only, right? Divided by v square means 1 plus x the whole square. So this will be minus 1 minus x. Here we get minus of minus x, which is plus x, divided by 1 plus x whole square. Here minus x and plus x will cancel each other. So we get minus 1 by 1 plus x square as our dy by dx, and that is what they are asking us to prove here, right? So hence proved, that's it. Okay, let us move on to the next sum. A die with number 1 to 6 is biased such that probability of 2 equal to 3 by 10 and probability of other numbers is equal. Find the mean of the number of times number 2 appears on the dice if the dice is thrown twice. Okay, so here we have to understand one thing. What do you mean by biased die, right? Biased die mean the probability of getting each number is not the same. Okay, maybe the die has a dent or some uneven shape so that it has a high chance to show 2 on the upper surface of it, right? So given probability of 2 is 3 by 10, and what they are saying, all the other numbers have the same probability. Okay, so now let us see probability of any number other than 2 I want to know. Okay, other than 2. That will be the complementary event, right? Not getting 2. So that will be 1 minus p of 2. So that will give me 1 minus 3 by 10, which is 7 by 10. Okay, so probability of getting a 2 is 3 by 10. Probability of not getting a 2 is 7 by 10. Okay, let us move on to the next thing. Now we are going to throw the dice 2 times. Okay, and they are asking us to find the mean for number of times the number 2 appears. Okay, let us think about that. I am rolling the dice 2 times. Okay, and I am noting down what number is appearing on the top surface of the die. Die is rolled twice. So there are 3 possibilities, right? What are the 3 possibilities here? I am not getting a 2 in the first throw, and I am not getting a 2 in the second throw as well. Okay, that is first possibility. So the number of times I am getting 2 means if I am counting how many times I got a 2, both the times I didn't get a 2, that means the number of times 2 appeared is 0 here, right? Number of times 2 appears is 0 here. Okay, and let us think about the next possibility. I can get a number other than 2 in the first die, and I can get a 2 in the next die. That is one possibility, or that can be the other way also. I can get a 2 in the first die or first throw and not a 2 on the next throw. So both of these are possible, right? In both of these situations, we can say how many times 2 appeared? Only once, right? So number of times 2 appears is 1. Okay. And what is the other situation we can have? 2 and 2. Both the roll can give me a 2 also. Okay. So this time, if I count how many times 2 appeared, it will be number of times 2 appears is 2 times it is appearing, right? So here all these is based on the random variable, right? So random variable is nothing but we are going to assign a number with a random experiment. Okay, so I am taking the random variable x as the number of times 2 appeared. Okay, so I am writing that here. Let x be the random variable which is the number of times 2 appeared when the die is thrown twice. So what are the possible values that x can take now? Let us see these 3 situations. In the first situation, if I count how many times 2 appeared, there is no 2 appeared. So x is taking the value 0 in the first situation, right? In the second situation, it is giving only 1 2 and the other number is not a 2. So that time x takes the value 1 because 2 appeared only once. And in the third situation, 2 appeared twice. So the number of times 2 appeared will be 2. So x can take the value 2. So x is the random variable which takes the values 0, 1 and 2. And we have to create the probability distribution table then only we will be able to find the mean of the distribution, right? For that, we need to find out probability of x equal to 0, probability of x equal to 1, and probability of x equal to 2 using these three possibilities. Okay, so probability of x equal to 0 means what? Probability of not getting 2 on both throws. Am I right? Both the throws should not give me a 2. That is the meaning, right? So that means probability of not a 2 and not a 2. So first throw also I am not getting a 2. In the second throw also I am not getting a 2. So this situation, if we want to convert to symbolic way, we can say this like probability of not a 2 into probability of not a 2, because whenever and appears we will put a multiplication symbol there. Whenever r appears we will put a addition symbol there. Okay, so not a 2 means probability of not getting 2, that is 7 by 10, right? We already have calculated it, and this one also 7 by 10. So this answer is 49 by 100. Okay, the same way probability of x equal to 1 means probability of getting 2 once in both the throws. That means probability of not 2 and 2, either this can be okay, or probability of 2 and not 2. So this will be and is there, so into symbol. So probability of not 2 into probability of 2, this is the first situation. R can be replaced with a plus, and here we can write it like P of 2 and is there into probability of not a 2. Okay, this will be 7 by 10 into 3 by 10, because we already know their probabilities, plus 3 by 10 into 7 by 10. So this will be 21 by 100 plus 21 by 100, which is equal to 42 by 100. Now we need to find out probability of x equal to 2. Probability of getting 2 in both the throws, right? Getting 2 in both throws. That means 2 and 2. Both time I should get a 2. That means P of 2 into P of 2, right? And is there, so into. So this will be 3 by 10 into 3 by 10, which is 9 by 100. So we are ready with all the probabilities. Now we have to create the probability distribution table. Then only we will be able to find out the mean of this distribution, right? So let us draw the table like this. Here we have x, here we have p of x. 0, 1, 2 are the possible values of x, and their probabilities respectively are 49 by 100, 42 by 100 and 9 by 100. Okay, so we are done with the table. Now we need to find the mean. So mean equal to sigma x into p of x. Correct? So that is equal to 0 into 49 by 100 plus 1 into 42 by 100 plus 2 into 9 by 100. Correct? So this will be like first thing will become 0, right? So leave it. 1 into 42 by 100 is 42 by 100. 2 into 9 by 100 is 18 by 100. And 100 can be taken as LCM. 42 plus 18 will be 60, right? 60 by 100 can be written like 6 by 10 or 0.6. So that is the mean. Okay. Let us move on to the other choice of this sum. Two dice are thrown. Defined are the following two events A and B. A equal to the set of all x comma y such that x plus y equal to 9, and B equal to set of all x comma y such that x is not equal to 3, where x comma y denote a point in the sample space. check if events A and B are independent or mutually exclusive. So whenever probability related sum is coming, we have to write the sample space without fail. So let us write it. So we have written the sample space here. So let us try to understand what is given in the event A. A is the collection of ordered pairs x comma y such that x plus y equal to 9. So two dice are thrown. We are noting down the numbers appearing on the top surface of both the dice. Yeah. So we are taking the number appearing on the first die as x and the second die as y, and we are adding them. We should get a 9 that time. So the favorable outcomes for that to happen will be 3, 6, 4, 5, 5, 4 and 6, 3. Correct? Only these four combinations will give us a total 9 when we add them. Right? So A will be the event having 3, 6, 4, 5, 5, 4 and 6, 3. So what is n of A? The number of elements in A is 4. And what about n of S? N of S is 36, right? There are 36 entries in our set S. So probability of A will be n of A divided by n of S, which is 4 divided by 36. Okay, let us not simplify, let it be as it is. And now let us try to find out the favorable outcomes for the event B. Okay, B is given like the collection of ordered pairs x comma y such that x is not equal to 3. What do you mean? See, we are throwing two dice again and we are taking the number appeared on the first die as x and the second die as y. The number showed on the first die should not be a 3. So what do we mean? We have to take all the numbers other than this row, right? Only this row has a 3 in the first position. So rest of all are fine for us, right? So that's what we are going to take now. So the favorable outcomes for B will be everything except the third row, right? So all these are okay. See, we don't have a problem having 3 in the second die. That's not a problem, okay? Try to understand that. Excluding the third row completely. So these many options are favorable for our B. Okay, so let us write the favorable outcomes for our event B. And n of B is 30 outcomes, right? Out of the 36, we are excluding 6. So the remaining 30 will be taken for favorable outcomes of B. So we have n of B 30 and probability of B will be n of B divided by n of S, which is equal to 30 divided by 36. Okay, so we are ready with the basic things. Now let us continue what we have to check here. Yeah, we have to check whether events A and B are independent or mutually exclusive events. So both the conditions we have to check. So what we are having here, P of A equal to 4 by 36 and P of B equal to 30 by 36. Okay, we are going to check for two conditions, whether A and B are independent and whether A and B are mutually exclusive. Okay, we know that A and B are independent events if probability of A intersection B equal to P of A into P of B. So let us see A intersection B here. This one is not in B, right? 3, 6 is not in B. So other than that, 4, 5, 5, 4, 6, 3, all these three elements are available in B also. So A intersection B will be 4, 5, 5 4 and 6 3. Okay, so n of A intersection B will be 3. So probability of A intersection B will be n of A intersection B divided by n of S, which is 3 by 36. Whatever we have obtained, I have written them here. Okay, now we know that A and B are independent events if P of A intersection B equal to P of A into P of B. Okay, now let us multiply P of A and P of B. This will be 4 by 36 into 30 by 36. Let us try to simplify here. So 4 1 time, 4 9 times, 6 5 times, 6 6 times. So we are getting 5 divided by 54 as the answer. And P of A intersection B equal to 3 by 36. If we simplify, we will get 1 by 12. Right? So now we can very well see that 5 by 54 is not the same like 1 by 12, right? So we can't say that. Therefore, P of A intersection B is not equal to P of A into P of B. That is what we are getting in this particular sum. Therefore, A and B are not independent events. Okay, A and B are not independent events. Now we have to check for the mutually exclusive events. Okay, so let us see what is the definition for that. A and B will be mutually exclusive if A and B have no common elements. I mean, A intersection B is empty. That is when we can say this. But look at this A intersection B, we had 3 entries, remember? So, in this particular sum, A intersection B equal to 3 items were there, right? What were they? 4 5, 5 4 and 6 3, right? So that implies A intersection B is not equal to empty. Therefore, we can conclude that A and B are not mutually exclusive. So what is our final conclusion? A and B are neither independent nor mutually exclusive. Both the conditions are not satisfied. Okay, so let us move on. Sum number 31. Find integral 1 by x root of x plus a by x minus a into dx. Okay, so now what we are going to do is, we are going to simplify the value inside the integration first, then only we can be able to integrate it nicely. Okay, so consider 1 by x into root of x plus a by x minus a. So that we are going to multiply by x plus a both in the numerator and denominator of the square root item. Okay, 1 by x we are not disturbing. This x plus a by x minus a, we are multiplying by another x plus a both in numerator and denominator, so that the value is not at all disturbed. So after that, what we are getting is, in the numerator we have x plus a into x plus a, and in the denominator we have x minus a into x plus a, and this can be written like 1 by x into root of x plus a whole square divided by a plus b into a minus b pattern is there in the denominator, which can be written like x square minus a square. Okay, and now we can split this square root into two terms, root of x plus a whole square divided by root of x square minus a square. Okay, and this will be like 1 by x into, in the numerator whole square and the square root will get cancelled, so we can write it like x plus a without any root. But in the denominator nothing happens like that, right? So we have to keep it as it is. So this is our final value of the value inside the integral, right? So Now we are going to take the integral and do the changes there. So therefore integral 1 by x into root of x plus a by x minus a dx can be written like 1 by x into x plus a by root of x square minus a square dx. Okay, and now we are going to split the fraction inside the bracket into sum of two fractions, like 1 by x into x by root of x square minus a square plus a by root of x square minus a square into dx. Okay, and this can be split into two integrals now, which is 1 by x into x by root of x square minus a square dx plus this 1 by x is common for the other one also. Don't forget that 1 by x into a by root of x square minus a square dx. And this can be the first integral, we can cancel x here, right? So it is integral dx divided by root of x square minus a square plus a can be taken outside of the second integral, and we have 1 by x into root of x square minus a square dx. And the first integral, we have a formula support. What is it? Integral dx by root of x square minus a square will be log modulus of x plus root of x square minus a square, right? And the second integral 1 by x into root of x square minus a square dx will be 1 by a secant inverse of x by a. Okay, that is the answer for the next integral. So let us put the values in here. So first integral's answer is log modulus of x plus root of x square minus a square plus a is already there, and the integral's answer is 1 by a secant inverse of x by a. Of course, plus constant of integration c. These two a's will cancel now, right? So we will have log modulus of x plus root of x square minus a square plus secant inverse of x by a plus c. That's the final answer. Let us solve section D long answer type 5 marks each. Sum number 32. Using integration, find the area of the region bounded by the line y equal to 5x plus 2, the x-axis and the ordinates x equal to minus 2 and x equal to plus 2. One thing we have to understand is when these type of sums are given, we need to do the integration, right, to find the area. But we need to know the graph of this curve before doing the integration. Why? Because that plays a vital role. Because otherwise, we will think that a equal to integral n limits of x are given. So minus 2 to plus 2. Then dx we will put here. So that time y we will put here. So this will be minus 2 to plus 2. 5x plus 2 times dx. Okay, this is what we will think if we don't draw the curve. Okay, if you ask me what's wrong in doing this seems correct only, right? But there is a thing we have to understand here. I'll tell you that. This is the graph of that line. Yeah, y equal to 5x plus 2. How did I draw this? See, we have to know at which point this curve touches x-axis, right? So for that, put y equal to 0. So 5x plus 2 equal to 0. This gives us 5x equal to minus 2, x equal to minus 2 by 5. Or we can think this like a decimal number also. If you want, you can write it like a minus 0.4, isn't it? So that's fine. Yeah, let us keep it minus 2 by 5 only. Nothing wrong. So this is that point, right? This is that point minus 2 by 5 comma 0. Okay, so only if we draw the curve, we will understand the curve is not behaving the same way in the entire gap between minus 2 and plus 2. Why? Because a portion of the curve lies below the x-axis and a portion of the curve lies above the x-axis, and the process of integration also changes according to this, right? You know well that when a curve lies below the x-axis, if you find the area directly, you will get the area as a negative quantity, which is not allowed. Why? Because area can never be negative. So for that type of situation, we will put integration of y dx inside a modulus symbol. I mean, we will take the absolute value of that value, the final value, because area can never be negative, right? So that thing we have to do for the green shaded region here, and the pink shaded region is the portion which lies above the x-axis, which is all fine. We don't need to do anything for that region. So the gap between minus 2 and plus 2 is now splitting into two zones. What are they? Minus 2 to the gap between minus 2 to minus 2 by 5, right? Or we can write it like minus 2 comma minus 2 by 5. Yeah, this is one region which lies below the x-axis, and again minus 2 by 5 to 2. This is another region. In this region, the curve lies above the x-axis. So whenever we draw the graph of the curve, we will get the clarity of all of these. Otherwise, we will end up having a wrong answer. Okay, so y equal to 5x plus 2 implies if y equal to 0, 5x plus 2 equal to 0, that gives you x equal to minus 2 by 5, as I told you. Therefore, the curve touches the x-axis at minus 2 by 5 comma 0. Okay, so because of this, we will do the integration split into two portions now. Area equal to integral minus 2 to plus 2 y dx. This is the usual thing we do, but we have to split it now. Minus 2 to minus 2 by 5 y dx plus minus 2 by 5 to plus 2 y dx. Okay. Hereafter everything is same way we have to do. Minus 2 to minus 2 by 5, 5x plus 2 dx plus minus 2 by 5 to 2, 5x plus 2 dx. And as I told you, this needs special attention. We have to put whatever we are getting in this answer in a modulus symbol. Okay. So that I am putting here also, because it's going to give you a negative value, right? We can write integral of ax plus b whole power n dx like ax plus b whole power n plus 1 by n plus 1 times a, right? This we can apply for this integration as a whole, and this answer becomes 5x plus 2 whole square divided by 2 into 5 between the limits minus 2 to minus 2 by 5 in a modulus plus 5x plus 2 whole square by 2 into 5 between minus 2 by 5 to plus 2. Okay, and continue further. This can be written like 5x plus 2 whole square by 10 between the limits minus 2 to minus 2 by 5 in a modulus plus 5x plus 2 whole square divided by 10 between the limits minus 2 by 5 to plus 2. And this we can write like 5 into minus 2 by 5 plus 2 whole square divided by 10 minus the lower limit value will be 5 into minus 2 plus 2 whole square by 10. All of these are in a modulus symbol, of course. Same goes well with the next one also, but there is no modulus here. So the upper limit value will be 5 into 2 plus 2 whole square divided by 10 minus, for the lower limit value it will be 5 into minus 2 by 5 plus 2 whole square divided by 10. Okay, and then inside the modulus we have these two 5's will cancel, right? So we will have minus 2 plus 2 whole square by 10 minus minus 10 plus 2 whole square by 10. Close the modulus, and again in the next thing it will be like 10 plus 2 whole square by 10 minus minus 2 plus 2 whole square by 10. So hope you know that this one becomes a 0 and this one becomes a 0, right? So we get modulus of minus 8 whole square, right? Minus of minus 8 whole square by 10 plus 12 square by 10. So this will become 64, but modulus is there minus 64. Modulus of that will be plus 64 by 10, and 12 square 144 by 10, and this will give you 208 by 10, which can be simplified like 104 by 5. Since this is the area, write square units here. That's the end of this sum. Let us move on to the next sum. Find integral of x square plus x plus 1 divided by x plus 2 into x square plus 1 dx. So by seeing the type itself, we can easily get the idea that this is of the partial fraction type. How did you find it out? The numerator's degree is 2, and the denominator's degree is 1 here and 2 here. Together it is 3. If the denominator's degree is more than the numerator's degree, then we should go for partial fraction type, right? Let x square plus x plus 1 divided by x plus 2 into x square plus 1 equal to a by x plus 2. So whenever we have a linear factor, in the numerator of that linear factor we will have to put a constant, right? And when we have a quadratic factor, we have to put a linear factor in the numerator, right? So this is what we have to put, and then we have to find the values of ABC here. So for that, let us take x plus 2 into x square plus 1 as the LCM for the right side. So this will give us a into x square plus 1 plus bx plus c into x plus 2 divided by x plus 2 into x square plus 1, right? In the LHS we have the same. Now comparing the numerators, we have x square plus x plus 1 equal to a x square plus a when we multiply with a inside for the first one, and the next two binomial factors also we have to multiply together. That will give us bx square plus 2bx plus cx plus 2c. Where let us combine the like terms together first, then we will write it properly. So this is how it should look, right? So now I am taking x square common from first two items. I will get a plus b in the brackets, and here if I take x common outside, I will get 2b plus c inside the brackets, and this a plus 2c both are non-variable terms, right? Constant terms. So finally we are having this. So when we have two quadratic equations equal to each other, their coefficients must be equal to each other, right? So that will happen. The coefficient of x square on the left side is 1 and the coefficient of x square on the right side is a plus b. So a plus b must be equal to 1. Let us call this our first equation. Same way, coefficient of x on the left side is 1 and coefficient of x on the right side is 2b plus c. So 2b plus c is equal to 1. That's our second equation. And same way, a plus 2c is also equal to 1. That is our third equation. I am planning to cancel c from second and third equations. Okay, let us see how to do that. Third equation I am writing as it is. Since b is not there, we can put a 0b here. A plus 0b plus 2c equal to 1. Okay, second equation, since we are planning to cancel c, we have to multiply second equation with the 2, right? So if we multiply second equation with the 2, we get a term is not there, so 0a we can write, and 2b into 2 will be 4b, and c into 2 will be 2c, 1 into 2 will be 2. Now if we subtract, okay, changing the signs, c will cancel. 1a minus 0a will be 1a only. 0b minus 4b will be minus 4b. And 1 minus 2 will be minus 1. Let us call this our fourth equation. Now I am planning to solve first and fourth equations for a. Okay, so I am taking equation number 1 as it is, a plus b equal to 1, and I am writing fourth equation also as it is, a minus 4b equal to minus 1. Now I am going to subtract again. Changing the signs, we get minus plus here and plus here. A cancels. Plus 4b plus b will be plus 5b. 1 plus 1 will be 2. So b's value equal to 2 by 5. Right? Now we can put this value in equation number 1 to find the value of a. So put b equal to 2 by 5 in first equation. A plus b equal to 1 implies a plus 2 by 5 equal to 1. That implies a equal to 1 minus 2 by 5, which is 3 by 5. That implies 2 into 2 by 5 plus c equal to 1, which is 4 by 5 plus c equal to 1, which implies c equal to 1 minus 4 by 5, which is 1 by 5. So let us get back to this starting point. Let us replace a, b, c's values now. So x square plus x plus 1 divided by x plus 2 into x square plus 1 equal to a by x plus 2 means 3 by 5 by x plus 2 plus bx plus c, which is 2 by 5x plus 1 by 5 divided by x square plus 1. Right? Or else we can rewrite this like 3 by 5 times 1 by x plus 2 plus from these two we can take a 1 by 5 common in the numerator, and we can write this like 2x plus 1 divided by x square plus 1. So instead of integrating the LHS, that's the question, right? We will integrate the RHS. For integral of x square plus x plus 1 divided by x plus 2 into x square plus 1 dx equal to integral of 3 by 5 into 1 by x plus 2 dx plus integral of 1 by 5 into 2x plus 1 by x square plus 1 dx. We can again write this like in 3 by 5 integral 1 by x plus 2 dx plus 1 by 5 integral 2x by x square plus 1 dx plus 1 by 5 integral 1 by x square plus 1 dx. This 2x plus 1 by x square plus 1 can be further split into two fractions, so which I have split into two integrals separately. Okay, and the first one is the substitution type. If we substitute x plus 2 equal to some t1, we can get dx equal to dt1. So we can straight away write this like 3 by 5, like log modulus of x plus 2 plus 1 by 5 into the second one also similar type only. If we take x square plus 1 equal to some t2 or whatever, 2x plus 0 or 2x dx will be dt. So integral of dt by t will give us log only, right? So 1 by 5 log modulus of x square plus 1. And the third one is also answer for tan inverse of x, right? So this will be 1 by 5 into tan inverse x plus constant of integration c. And this is the final answer. Let us move on to the next sum. Sum 34 has two choices. The first one is find the shortest distance between the lines x plus 1 by 2 equal to y minus 1 by 1 equal to z minus 9 by minus 3 and x minus 3 by 2 equal to y plus 15 by minus 7 equal to z minus 9 by 5. So, I have line 1 like a1 bar plus lambda times b1 bar, and line 2 like a2 bar plus mu times b2 bar. Then shortest distance will be a2 minus a1 dot b1 cross b2 divided by length of b1 cross b2 all in a modulus, right? So this is what we have for the shortest distance, right? Now if we have the vector form of the line, then that would be very easier, but here we have the Cartesian form of the lines. So we have to find out the point on the line, and we can take it like a1 bar and the drs of the line as b1 vector and b2 vector. Okay, so let us write L1 x minus of minus 1 by 2 equal to y minus 1 by 1 equal to z minus 9 by minus 3, right? So a1 bar is the point through which the line is passing, right? So a1 bar will be, take all the values which are coming after the x, y, z, right? So minus 1 into I vector plus 1 into j vector plus 9 into k vector. So why we are doing so? We have to compare with x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. So x1, y1, z1 is the points coordinates, right? So that will be like minus 1 plus 1, 9. So a1 will be this, and the b1 vector is the drs, right? So that will be like 2i plus 1j plus minus 3k. So these are the drs, right? These are the drs of the line 1, right? So with ijk we can write like that. The same way, take L2 now, x minus 3 by 2 equal to y minus of minus 15 by minus 7 equal to z minus 9 by 5. So here also a2 will be, x1 is 3, right? So 3i, y1 is minus 15, so minus 15j, and z1 is plus 9, so plus 9k. Okay, and b2 will be the drs of the line 2, which are 2 minus 7 and plus 5, right? So those we have to take 2i minus 7j plus 5k. So once we get our a1 b1 a2 b2s ready, we can easily continue with the rest of the process. First we need a2 minus a1. So a2 minus a1 will be 3i minus 15j plus 9k minus I plus j plus 9k. And this will be 3 minus of minus 1 will be 4i minus 15 minus 1 will be minus 16j plus 9 minus 9 will become 0. So 0k. So this is nothing but 4i minus 16j. Okay, and then B1 cross B2 we have to find out. Let us do that. B1 cross B2 equal to determinant ijk. The coefficients of B1 are 2, 1, minus 3 and the coefficients of B2 are 2, minus 7, 5. Okay, let us expand this. I minor of I is 1 minus 3 minus 7 5 minus j and j's minor 2 minus 3 2 5 and plus k and k's minor is 2 1 2 minus 7. And expanding further we get 5 minus 21 minus j into 10 plus 6 plus k into minus 14 minus 2. This will be I into minus 16 minus j into 16 plus k into minus 16. So this is minus 16i minus 16j minus 16k. Okay. Now length of B1 cross B2 also we need to find out. Length of B1 cross B2 will be square root of minus 16 square plus minus 16 square plus minus 16 square. This will be root of 256 plus 256 plus 256 and that will be 3 times 256, right? And that will be 16 root 3. Okay, so now let us continue further. Shortest distance equal to a2 minus a1 dot b1 cross b2 divided by length of b1 cross b2, everything in a modular symbol. So this will be a2 minus a1 was 4i minus 16j dot b1 cross b2's value is minus 16i minus 16j minus 16k divided by length of b1 cross b2 is 16 root 3. And this will be the dot product of both the vectors in the numerator will be 4 into minus 16, which are the coefficients of I, and then minus 16 into minus 16, which are the coefficients of j, and 0 into minus 16, which are the coefficients of k, since k is not there in the first a2 minus a1 vector, divided by 16 root 3. So this is equal to minus 64 plus 256 divided by 16 root 3. This will be 192 divided by 16 root 3. We can cancel with the 16 here, right? So this will become 16 one time, balance 3, 32. 16 2s are 32. 16 is fully gone here. So 12 divided by root 3. We can't leave it this way. We have to rationalize this. So multiplying by a root 3 and dividing by a root 3, we get 12 root 3 divided by 3, which is 4 root 3. Units we have to give because this is the distance, right? And that's all for the sum. Let us move on to the next one. The next choice of the same question. Find the image A dash of the point A212 in the line L given as R bar equal to 4i plus 2j plus 2k plus lambda times I minus j minus k Also find the equation of line joining A dash. Find the foot of the perpendicular from point A on the line L. Okay, now let us draw the line so that we understand the scenario better. Suppose if this is the line, okay, and let this be the point A, which is 2, 1, 2, and let this be the image of A, which is A dash given. Okay, we can call its coordinates like alpha, beta, gamma, and we know that A dash will be perpendicular to this line L, right? And let the point where the A dash line meets this line L will be point P. Start solving this. Let P be the general point on the line L, which is the point of intersection of A dash and the line L, where A dash is alpha, beta, gamma. Okay, we need to find the coordinates of the point, general point P. We can easily do that from the given lines equation, right? L is given like 4i plus 2j plus 2k plus lambda times I minus j minus k. This can be written like 4i plus 2j plus 2k plus lambda I minus lambda j minus lambda k. This can be written like 4 plus lambda times I plus 2 minus lambda times j plus 2 minus lambda times k. P is 4 plus lambda comma 2 minus lambda comma 2 minus lambda. So AP perpendicular to the line means dot product of the DRs will be 0, right? That concept we can use here. For that we need the DRs of AP, line segment AP. DRs of AP will be 4 plus lambda is the x coordinate of P and 2 is the x coordinate of A. So minus 2 we have to put, right? Comma y coordinate of P minus y coordinate of A and z coordinate of P minus z coordinate of A. Then R that can be simplified like 2 plus lambda. 2 minus 1 is 1, 1 minus lambda. 2 minus 2 is 0, just a minus lambda. Okay, this is the DRs for the line AP. And of course, the lines DRs we know well. How? Because this is the parallel vectors DRs, right? That will be the same for the given line also, right? So, DRs of the given line are 1 minus 1 minus 1, right? So, now we are going to apply the concept. Since AP perpendicular to the line L, dot product of DRs will be 0, right? Will be 0. So, that implies dot the lines DRs are 1 minus 1 minus 1. This should be 0. So, that implies 2 plus lambda into plus 1 plus 1 minus lambda into minus 1 plus minus lambda into minus 1 should be equal to 0. Yeah, simplifying further, we have 2 plus lambda into 1 is 2 plus lambda only. 1 minus lambda into minus 1 will be minus 1 plus lambda. Minus lambda into minus 1 will be plus lambda. This is equal to 0. That implies 2 minus 1 is 1 plus 3 lambda equal to 0. That implies 3 lambda equal to minus 1. So lambda equal to minus 1 by 3. So now we can write the coordinates of P very clearly, right? 4 plus lambda, 2 minus lambda, 2 minus lambda will now be equal to 4 plus of minus 1 by 3 is 4 minus 1 by 3. And 2 minus of minus 1 by 3 will be 2 plus 1 by 3. The same is the next case also. That is P is 4 minus 1 by 3 is 11 by 3. 2 plus 1 by 3 is 7 by 3. The next one is also 7 by 3. Yeah. So now what we can say is A dash midpoint is P, right? How can we say that? Because we very well know that the distance between the mirror and the object will be the same like the distance between the mirror and the image, right? So distance between A and P will be the same like the distance between A dash and P. Or we can say A dash's midpoint will be P, right? So that's what we are going to apply now. P is the midpoint of A dash. Therefore, x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. That's the midpoint of A dash right now. And P's value is 11 by 3, 7 by 3, 7 by 3. And we know that A point's coordinates are 2, 1, 2, right? So 2, and we have kept the coordinates of A dash like alpha, beta, gamma. So it will be like 2 plus alpha by 2 and 1 plus beta by 2 and 2 plus gamma by 2 equal to 11 by 3, 7 by 3, 7 by 3. Okay. And solving further, we get 2 plus alpha by 2 equal to 11 by 3. That implies 3 times 2 plus alpha equal to 11 into 2, 22 by cross multiplication. This gives us 6 plus 3 alpha equal to 22. This gives us 3 alpha equal to 22 minus 6, which is 16. That implies alpha equal to 16 by 3. Okay, same way we have to do for the other values also. So 1 plus beta by 2 equal to 7 by 3 implies 3 times 1 plus beta equal to 7 2s are 14. That implies 3 plus 3 beta equal to 14. That implies 3 beta equal to 14 minus 3. That implies 3 beta equal to 11. So beta equal to 11 by 3. And the third thing will be 2 plus gamma by 2 equal to 7 by 3 implies 3 into 2 plus gamma equal to 7 into 2, 14. That implies 6 plus 3 gamma equal to 14. That implies 3 gamma equal to 14 minus 6, which is 8. That implies gamma equal to 8 by 3. So, therefore, A dash's value will be 16 by 3, 11 by 3, 8 by 3. And in the question, they are asking the equation of the line segment A dash also. Okay, they are asking find the equation of the line joining A dash and find the foot of the perpendicular from point A on the line, means that is the point P, right, which we have already found. The only left thing will be equation of A dash. The point A is already given, which is 2, 1, 2. and the point A dash just a while ago we found it, which is 16 by 3, 11 by 3 and 8 by 3. Let us call this like x1, y1, z1 and this like x2, y2, z2. The equation of A dash will be x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. That implies x minus 2 by 16 by 3 minus 2 equal to y minus 1 by 11 by 3 minus 1 equal to z minus 2 by 8 by 3 minus 2. Simplifying further we have, and continuing further we have x minus 2 by 16 minus 6 by 3 is 10 by 3 equal to y minus 1 by 8 by 3 equal to z minus 2 by 2 by 3. Or this 3 can go to the numerator, right? Denominator can go to the numerator, and finally we can write this like 3 times x minus 2 by 10 equal to 3 times y minus 1 by 8 equal to 3 times z minus 2 by 2. And we can't leave this way. Why? Because these are the DRs of the line AA dash, right? They are not supposed to have any common factor here. In case if they have any common factors, we have to divide by the HCF. Okay, so the common factor for 10, 8 and 2 is 2. So we have to divide all the denominators with the 2, so that we get here 3 into x minus 2 by 10 by 2 equal to 3 into y minus 1 by 8 by 2 equal to 3 into z minus 2 by 2 by 2. We can do this because we are dividing every denominator with the same number, so nothing is going to get affected. So finally we get 3 into x minus 2 by 5 equal to 3 into y minus 1 divided by 4 equal to 3 into z minus 2 by 1. So this is the equation of A dash. Okay, that's the end of the sum. Let us move on to the next sum. Sum 35 has two choices. The first one is given matrix A equal to minus 4, 4, 4, minus 7, 1, 3, 5, minus 3, minus 1, and matrix B equal to 1, minus 1, 1, 1, minus 2, minus 2, 2, 1, 3. Find AB. That's the first question. And hence solve the system of linear equations. So finding AB will give us a clue about the A inverse value, which we can take for help and continue further to solve the system of linear equations. Okay, so let us find AB first. So A into B equal to minus 4, 4, 4, minus 7, 1, 3, 5, minus 3, minus 1 into 1 minus 1, 1, 1 minus 2, minus 2, 2, 1, 3. And the product of these two matrices we have to do. So the first row and first column product will be minus 4 into 1 plus 4 into 1 plus 4 into 2. That's the first entry of the answer matrix, right? So then the product of the first row and the second column will be minus 4 into minus 1 plus 4 into minus 2 plus 4 into plus 1. That's the second entry of the answer matrix. And first row and third column product will be minus 4 into 1 plus 4 into minus 2 plus 4 into 3. Okay, that's the end of the first row. Now second row first column answer will become our second row first column entry, right? So it will be like minus 7 into 1 plus 1 into 1 plus 3 into 2. Same way, second row into second column will be minus 7 into minus 1 plus 1 into minus 2 plus 3 into 1. Second row third column will be minus 7 into 1 plus 1 into minus 2 plus 3 into 3. Third row first column will be 5 into 1 plus minus 3 into 1 plus minus 1 into 2. And third row second column will be 5 into minus 1 plus minus 3 into minus 2 plus minus 1 into plus 1. And third row third column will be 5 into 1 plus minus 3 into minus 2 plus minus 1 into plus 3. And simplifying this further, we have minus 4 plus 4 plus 8, 4 minus 8 plus 4, minus 4 minus 8 plus 12, minus 7 plus 1 plus 6, 7 minus 2 plus 3, minus 7 minus 2 plus 9, 5 minus 3 minus 2, minus 5 plus 6 minus 1, 5 plus 6 minus 3. Okay, and then simplifying further, minus 4 plus 4 plus 8 will be 8, 4 minus 8 plus 4 will be 0, minus 4 minus 8 plus 12 will be 0, minus 7 plus 1 plus 6 will be 0, 7 minus 2 plus 3 will be 8, and minus 7 minus 2 plus 9 will be 0, and 5 minus 3 minus 2 will be 0, minus 5 plus 6 minus 1 will be 0, and 5 plus 6 minus 3 will be 8, which can be written like 8 into 1 0 0 0 1 0 0 0 1, which is the identity matrix, right? So 8 times identity matrix is the answer for AB. Okay, so A into B equal to 8i was the thing we found here. Given system of equations are, okay, and this we can write as a matrix product of 1 minus 1 1, 1 minus 2 for the second row, 2 1 3 for the third row into xyz equal to 4 9 1, right? So if we write this linear equations as a matrix product, this will be the product of them, right? We usually call this like our capital X, and we will call this like our capital B usually, but since B is already used in this, we are going to call this like the C matrix. Okay, now see the coefficients we have written: 1 minus 1 1, 1 minus 2 minus 2, 2 1 3, and look at our B matrix: 1 minus 1 1, 1 minus 2 minus 2, 2 1 3, which is the same thing we have here. So this is nothing but our B matrix given. So Bx equal to C is the matrix equation we are getting here, right? So that implies Bx equal to C. How can I find x here? That implies x will be B inverse into C. Okay, how can I find B inverse? No need to worry, here we can easily do that. So AB equal to 8i implies AB divided by 8 equal to I, right? Or else I can call this like A by 8 into B equal to I. See, we usually know that B inverse into B is equal to I. So that means A by 8 is our B inverse. Correct? So that is what we are going to use here. B inverse we will take like 1 by 8 times A, which is equal to 1 by 8 times matrix A is given like minus 4 plus 4 plus 4, minus 7, 1, 3, 5 minus 3 minus 1. Okay, this is our B inverse, which is what we are going to put here. Okay, so that implies x equal to 1 by 8 into minus 4, 4, 4, minus 7, 1, 3, 5 minus 3 minus 1, and the matrix C will be 4, 9, 1. Okay, all we need to do is the matrix product on the right side. So let us keep 1 by 8 as it is right now, and we will multiply B inverse and C matrices together. Okay, let us see what happens. First row into first column will be minus 4 into 4 plus 4 into 9 plus 4 into 1. Second row first column's product will be minus 7 into 4 plus 1 into 9 plus 3 into 1. And third row first column's product is 5 into 4 plus minus 3 into 9 plus minus 1 into 1. So LHS we had x, remember? So that implies x equal to 1 by 8 into, let us simplify this, minus 16 plus 36 plus 4. Next row will be minus 28 plus 9 plus 3. The next row will be 20 minus 27 minus 1. Okay, and that will give us x equal to 1 by 8 into, and that implies matrix x was xyz, right, which is equal to, let us multiply each value inside the matrix with 1 by 8. We get 24 by 8 minus 16 by 8 minus 8 by 8. And this will be equal to 3 minus 2 minus 1. So that implies x equal to 3, y equal to minus 2, z equal to minus 1 will be the solution for the given system of equations. Okay, so that's the end of the sum. Let's move on to the next one. The second option of the same sum is, if matrix A equal to 1, 2, 0, minus 2, minus 1, minus 2, 0, minus 1, 1, then find A inverse. Hence solve the system of linear equations. So again, we need to find A inverse, and that is going to give us a clue about A inverse, and that we have to use for our solution of the upcoming system of equations. So let us see how to do that. And you know that the formula for finding A inverse will be 1 by determinant of A into adjoint matrix of A. First let us find determinant of A, which is determinant of 1, 2, 0, minus 2, minus 1, minus 2, 0, minus 1, 1. This will be 1 into 1's minor is minus 1, minus 2, minus 1, 1, minus 2 into 2's minor is minus 2, minus 2, 0, 1, plus 0 into 0's minor is minus 2, minus 1, 0, minus 1. And the answer for this is 1 into minus 1, minus 2, minus 2 into minus 2 plus 0. This is going to be 0 only, so I am not going to expand it. So this will be 1 into minus 3, minus 2 into minus 2, which is minus 3 plus 4, which is 1. So determinant of A is 1 now. Now we need to find out the adjoint matrix of A, right? So let us do that. Adjoint matrix of A will be, so the minor of 1 will be minus 1, minus 2, minus 1, 1. And this guy's sign is positive. And the minor of 2 will be having a minus sign. And its minor will be minus 2, minus 2, 0, 1. And the minor of 0 will be having a plus sign. And it is minus 2, minus 1, 0, minus 1. And the minor of the second row first entry, minus 2, will be having a minus sign, and its minor will be 2, 0, minus 1, 1 with a minus sign. Okay, and the minor of the second row second entry will be having a plus sign, and that's minor is 1, 0, 0, 1. And the minor of the third entry of second row will be 1, 2, 0, minus 1 with a minus sign. Okay, and the third row first entry is minor will be having a plus sign, and its minor will be 2, 0, minus 1, minus 2, and the minor of the third row second entry will be having a minus sign, and that is 1, 0, minus 2, minus 2, and the minor of the third row third entry will be 1, 2, minus 2, minus 1. So all of this we have to put in a matrix applied with a transpose, right? Okay, now let us simplify this. So finally our adjoint matrix of A will be minus 3, minus 2, minus 4. Why? Because we are going to take the transpose, writing the columns as rows and rows as columns. We have this, right? 2, 1, 2, 2, 1, 3. So this is our adjoint matrix. Okay, let us find the value of A inverse. So A inverse equal to 1 by determinant of A into adjoint matrix of A. That will be 1 by determinant of A was 1, remember. So 1 by 1 into adjoint matrix of A is minus 3, minus 2, minus 4, 2, 1, 2, 2, 1, 3. 1 by 1 doesn't have any impact, right? So A inverse is equal to adjoint of A only, finally. Okay. So that's our A inverse. Now let us write the given system of equations. Okay. That can be written as a matrix product like taking all the coefficients alone, we have 1, minus 2, 0, 2, minus 1, minus 1, 0, minus 2, plus 1. That is the coefficient matrix, right? Into the variable matrix is x, y, z, and the other side is 10, 8, 7. Okay, for our reference, I am writing the given A matrix here. So we are going to get something from there, okay? So I am writing the matrix A given to us. This was our A. Compare these two now. Okay, what is this matrix now in the coefficient place? That is the transpose of A, right? Okay, we are going to take that help here. So that implies the first matrix is nothing but A transpose into capital X, we call it usually, right? X, Y, Z, the variable matrix. The other side we can call with any name. Let us call it like B here. Okay, if we have something like that, how can we find the value of X? That will be obtained by taking this A transpose to the other side. It will give you A transposes inverse times B. Correct? But how can I find A transposes inverse? We have A inverse already, right? So we have one formula which says A transpose inverse is the same like A inverses transpose, right? This we are going to apply here. So let us apply that. A inverses transpose into B will give us the value of X. See, A inverse is here. So we can easily take the transpose of that and write here. That will be minus 3, 2, 2, minus 2, 1, 1, minus 4, 2, 3. That's the transpose of A inverse, right? And B matrix is nothing but 10, 8, 7. If we multiply these two, that is going to give us the value of the variable matrix, right? Let us do the product here. Minus 3 into 10 plus 2 into 8 plus 2 into 7 minus 2 into 10 plus 1 into 8 plus 1 into 7 minus 4 into 10 plus 2 into 8 plus 3 into 7. That is going to give us the variable matrix which is xyz, which can be written like 0, -5, -3, right? That implies x equal to 0, y equal to -5, z equal to -3. So those are the required values, and that's the end of the sum. Let us solve section E, case study based questions carrying 4 marks each. Let's see the first sum in the case studies. Sum number 36. A school is organizing a debate competition with participants as speakers, S equal to S1, S2, S3, S4, and these are judged by judges J equal to J1, J2, J3. Each speaker can be assigned one judge. Let capital R be a relation from the set S to J defined as capital R equal to set of all ordered pair x comma y such that speaker x is judged by judge y, where x is from the set S and y is from the set J. Okay, so this relation is having the ordered pair x comma y such a way that the first element is the speaker and the next element is a judge. Okay, so this is the given scenario. Now we have to solve the sums from this. Based on the above, answer the following. How many relations can be there from the set S to set J? So S is given to be S1, S2, S3 and S4. So how many elements are there in our set S? 4 elements, right? And set J is given to be J1, J2, J3. So how many elements are there? 3 elements. Okay. So think about this. A relation is a subset of the cross product of both the sets. Okay. So if we do S cross J, how many elements will be there in S cross J? That we can easily find by multiplying the number of elements in S and number of elements in J, right? So S cross J will contain 12 elements in total. Okay. So based on that, we can easily find the number of relations defined on that. Okay. Let us see how number of elements in the cross product of S and J will be 4 into 3 will be 12. Okay. Now number of relations they are asking, right? Number of relations from S to J will be 2 to the power of number of elements in S cross J, right? 2 to the power of 12. That is the answer. Yeah. So we have a formula for this. That's how we found this. If set A has m elements and set B has n elements, then the number of relations possible from A to B is 2 to the power of m times n, right? So in this particular scenario, m is 4 and n is 3. That's how we are putting 2 to the power 12 as the required answer. Okay, let us see the next one. Number 2. A student identifies a function from S to J as f equal to S1, J1, S2, J2, S3, J2, S4, J3. Check if it is bijective. So, a student is saying this particular f is a function. Now we need to check whether this function is a bijective function. So what do you mean by bijective function? A function which is one-to-one as well as onto will be a bijective function, right? So let us see. Let us take the domain of F here and codomain of F here. Okay, look at the values here. First entries here S1, S2, S3, S4. So we can put them here S1, S2, S3, S4. So basically all elements of set S are here, and in the codomain we have J1, J2, J3. We are not allowed to repeat the same entry twice. So J2 we have to write once, right? Now let us draw arrows depending on the situation given. So S1 and J1 are related, and S2 and J2 are related, and S3 and J2 are also related, and S4 and J3 are related. Okay, so bijective means one to one and on to. If you take S2 and S3, they are having the same image. Yeah, for one to one this may not happen, right? So let us write here f of S2 equal to J2, and f of S3 is also J2. That implies f of S2 equal to f of S3, but S2 is not equal to S3. So images are the same means the elements also should be the same. That is the condition for one to one, right? S2 equal to S3 we should get. But here S2 is a different student, S3 is a different student. They are not the same, right? So that implies F is not one to one. Okay, and now checking for on to condition. What do you mean by on to? If you take any entry from the codomain, it should have some mapping coming from the domain. None of the elements in the codomain are allowed to be free without receiving any mapping, right? That is the condition we need to check for onto. Here see J1, J2, J3 all are receiving mappings from the domain. So none of them are free. So we can say F is onto here. But see, when we have both the conditions satisfied, that is when we call it bijective. But one to one is not satisfied. Only onto is satisfied. So we can't accept that F is bijective, right? Therefore, F is not a bijective function. If you ask me, is it a function? Of course it is. Yeah, but it is not a bijective function. Okay, so let us move on to the next subpart. The third one has two choices. The first one is how many one-to-one functions can be there from set S to set J. In our set S, we have 4 elements, and in our set J, only 3 elements. Okay, if you want one-to-one to exist, yeah, each of these S1, S2, S3, S4 has to give mapping to different entries. So one more entry was supposed to be there in the set J. Otherwise, we can't give the arrows like that. Okay, what I mean is, suppose if I have like this, one guy is left behind, right? One guy is left behind. So for this guy, if there is another entry on the set J, then this would have been a one-to-one function, right? So there is no one-to-one function possible from the set S to set J, since set S has more elements than J. Okay, this is one important thing we have to remember here. Okay, let us write the answer now. N of S, number of elements in S, is bigger than N of J, right? If it was the other way, okay, suppose if I had only 3 entries in the set S and 4 entries in the set J, then I can nicely have one-to-one function like giving mapping to any of the other elements, right? One element can be free in the codomain, remember? That is not a problem. So this way I can give so many one-to-one functions, right? But now we can't have because n of s is bigger than n of j. Okay, that is what we are going to write now. N of s is greater than n of j, therefore there cannot be any one-to-one function possible from s to j. Okay, that implies number of one-to-one functions from s to j will be 0. See, not even one function is possible. So how many functions are possible means there is nothing possible. So we have to give it as a 0. Okay, now let us see the next option of this. Another student considers a relation R1 equal to S1, S2, S2, S4 in set S. Write minimum ordered pairs to be included in R1 so that R1 is reflexive but not symmetric. Okay, let us see. Write R1 given S1, S2 and S2, S4. So R1 is x comma y where both x and y are from the set S only. Okay, so remember set S has 4 entries S1, S2, S3, S4. So if you want R1 to obey the reflexive property, all the elements of set S should be related to themselves, right? So if R1 is reflexive, then A comma A belong to R1 for every A belong to set S. Correct? So in order to satisfy that, we should have S1 comma S1 in R1. Yeah. And S2 comma S2 and S3 comma S3 and S4 comma S4 belong to R1. Okay. But they are not there in R1. So we have to include them. Then only R1 becomes reflexive, right? Symmetric should not be satisfied. So not a problem. S1, S2 can be there. S2, S1 will never be in R1 anyhow. Yeah, we have not included something like that. Same way, 2 S4 is there, but S4, S2 is not given by us. So symmetric will not be satisfied obviously. So all we need to do is just add these 4 entries inside our R1. That's enough. Okay. So R1 should be equal to S1 comma S2, the ones given by them. We will write them as it is. And then these 4 ordered pairs we will include. So you can easily verify here. Only reflexivity will be satisfied. Symmetric property won't be satisfied. And of course, transitive is also not satisfied, but they are not asking about this. So let's not worry about that. This is the minimum number of ordered pairs we have to include. Okay. So that is the end of the first case study. Let's move on to the next one. 3 persons wise, Amber, Bonzi and Comet are manufacturing cars which run on petrol and on battery as well. Their production share in the market is 60%, 30% and 10% respectively. Of their respective production capacities, 20%, 10% and 5% cars respectively are electric or battery operated. Okay, based on the above, answer the following. Okay, so to have a summary of the given thing. Okay, there are 3 persons who are manufacturing cars. Okay, and the cars of 2 types they are manufacturing. They can run on petrol or they can be electric vehicles also. Every one of them, petrol and electric. The production share in the market is given. Okay, what do you mean by production share? See, out of the 100% cars available in the city, 60% of the cars are produced by Amber, and 30% of the cars are produced by Bonzi, and 10% of the cars are produced by Comet. Okay, that's the given information. Of their respective production capacities, 20%, 10%, and 5% cars respectively are electric. I mean, out of the 60% produced by Amber, 20 are electric vehicles. Out of the 30% vehicles produced by Bonzi, 10% are electric among them, etc. Okay, this is the information given. We need to answer the following questions. So, one has 2 choices here. The first one is, what is the probability that a randomly selected car is an electric car? So we need to assign events for each and everything, right? So let A be the event that Amber manufactures the car. And B be the event that Bonzi manufactures the car. And C be the event that Comet manufactures the car. And let E be the event of selecting an electric car. Okay, so we have defined the events. Let us see the probabilities respectively. Probability of A will be the amount of cars manufactured by Amber. It is given that he is manufacturing 60%, right? It is 60 by 100. That can be simplified also, but let us keep it that way only. And the probability that Bonsai manufactures the car will be 30% of the cars are manufactured by Bonsai, remember? So this is 30 by 100. And the probability that the car is manufactured by Comet will be 10%, right? 10 by 100. Now we need to find out the probability of the selected car is an electric car. So we know that it is Amber manufacturing the car, the chances of Amber manufacturing one electric car will be 20%, right? So it will be 20 by 100. And provided that Bonsai is manufacturing the car, what is the probability that it can be an electric car? It is 10%, right? So it will be 10 by 100. And provided that Comet is manufacturing the car, the probability for that car to be electric will be 5% chances are there, 5 by 100. Now we need to find out probability of E, the total probability that can be obtained by P of A into P of E given A plus P of B into P of E given B plus P of C into P of E given C. Correct? This will be 60 by 100 into 20 by 100 plus 30 by 100 into 10 by 100 plus 10 by 100 into 5 by 100. And this will be Let us cancel only 1 0 here. This can be written like 120 by 1000 plus 30 by 1000 plus 5 by 1000. This can be written like 155 by 1000, and we can simplify this with a 5. 31 divided by 200, right? So this is the probability of E. Okay, let us see the next choice. What is the probability that a randomly selected car is a petrol car? A is the event that Amber manufactures the car, and B is the event that Bonsai manufactures the car, and C be the event that Comet manufactures the car. And let P be the event that the selected car is a petrol car. Okay, now they are asking what is the probability of the selected car is a petrol car. Okay, so again P of A is 60 by 100. We have already written this in the previous option as well. 30 by 100, and P of C is 10 by 100, same. Okay, and probability of P given A. Okay, what I mean is, if I know that Amber manufactures the car, what is the probability that it is a petrol car? Okay, we don't know that, right? Only given thing in the question is 20% of the cars produced by Amber are electric. So the rest of the 80% cars will be petrol model only, right? Same way, 10% are electric produced by Bonsai. So 90% of the cars produced by Bonsai will be petrol model. 5% of cars produced by Comet are battery operated. So the remaining 95% will be petrol model only, right? So that's how we have to do it. Let's see. Provided Amber manufactures the car, what is the probability that it is a petrol car? It will be 80 by 100. The same way, now that Bonsai manufactures the car, what is the probability that it is a petrol operated? It will be the opposite of the given 10%, right? So 1 minus 10 by 100, which is 90 by 100. Same way, probability that Comet produced the car, what is the chance that it is a petrol operated? It will be like 1 minus 5%, which is 95% or 95 by 100. Okay, now what we need to do is probability of P we have to find out. It will be like P of A into P of P given A plus P of B into P of P given B plus P of C into P of C given B. This will be 60 by 100 into 80 by 100 plus 30 by 100 into 90 by 100 plus 10 by 100 into 95 by 100. Here also I am going to cut only 1 0. So we will have 480 by 1000 plus 270 by 1000 plus 95 by 1000, right? So when we add all of them together, we will get, so 845 by 1000 equal to, we can cut with a 5, right? So 5 1 time, balance 3, 34, 5 6 time, balance 4, 5 9 times 45, here it is 200. So 169 by 200 is the required answer. Okay, let us move on to the next one. A car is selected at random and is found to be electric. What is the probability that it was manufactured by Comet? So this is the reverse probability. So the car is electric is the event which is already happened. Now we need to find out what is the chance that it was manufactured by comet. So this is the reversal. We have to apply Bayes theorem here. So probability, the event of being electric vehicle is already happened. So E has already happened because we have already defined the car is electric as a event E. Now what is the probability of C given E? We need to find this. So this can be done by probability of C into probability of E given C. Probability of A into probability of E given A plus probability of B into probability of E given B plus probability of C into probability of E given C. So this is equal to P of C is 10 by 100, hope you remember, and probability of E given C is 5 by 100, okay, divided by the value in the denominator is nothing but the total probability of E, right? P of E, correct? The denominator is nothing but P of E, right? So we can rewrite this like P of E, and this will be like we can cut one zero as usual. This is like 5 by 1000 in the numerator. And what is the answer for P of E? P of E was 155 by 1000 or 31 by 200. We can write whatever. I am going to write it like 155 by 1000. So here it is 155 by 1000. Okay. And you guys know that we can flip the fractions and multiply. So this will be like 5 by 1000 into 1000 divided by 155. Both the thousands will cancel, right? So it will be like 5 by 155. This can be simplified with a 5 like 1 by 31. Okay. So this is the final answer for this. Let's move on to the next one. A car is selected at random and it is found to be electric. What is the probability that it was manufactured by Amber or Bonzi? Okay. So what do you mean by this is probability of, see, being electric has already happened. So E has already happened. Amber or Bonzi means A or B given E. This we need to find out. Okay. So this is very difficult to do directly, but we can apply one trick here. See, Amber produces or Bonzi produces means Comet is not producing it. I mean, this is the opposite of P of C given E. Correct? So that can be written like 1 minus P of C given E because we know that P of A bar will be 1 minus P of A, right? So applying that, we can write the complements probability like 1 by 1 minus P of C given E, and C given E we have already done in the previous subpart 1 by 31. So that we are going to write here. So 1 minus 1 by 31 will be 30 by 31 if we take 31 as the LCM. Okay, this can be easily done. If you directly go now, that will take a lot of time to finish. So this is the easiest way. Yeah, so that's the end of this second case study. Let us see the third one. A small town is analyzing the pattern of a new street light installation. The lights are set up in such a way that the intensity of light at any point x meters from the start of the street can be modeled by f of x equal to e power x into sin x, where x is in meters. Based on the above, answer the following. Okay, don't take this too seriously, right? Just we are getting into the scenario. That's the meaning here. So what is given is, see, suppose if this is the beginning of the street, starting of the street, and if these are the lights arranged in the street like this, distance between the street and the first light, and distance between the street starting and the second light, starting and the third light, starting and the fourth light, everything. Okay, if that is taken as x meters, that can be easily written as an equation in this way. Okay, that is what is given. Okay, now we need to answer the following questions based on the given information. Find the intervals on which f of x is increasing or decreasing where x belong to the closed interval 0, pi. So we very well know that to tell the nature of the function, whether it is increasing or decreasing, we should know about the critical points, right? So first target is to find the critical points of f of x. So let us take our f of x given. F of x equal to e power x sin x. Okay, so let us find f dash of x now. So we have to apply UV method, right? So e power x kept idle, the differentiation of sin x is cos x. Sin x kept idle, e power x's derivative is also e power x. Now we can take e power x common from both the terms and we can write it like cos x plus sin x. Okay, this is our f dash of x's value, and we need to set f dash x equal to 0 to find the critical points, right? That implies e power x into cos x plus sin x equal to 0. E power x never becomes 0, remember, because the curve e power x will never touch the x-axis. So it will never take the value 0. So only the value in the brackets will make the product equal to 0, right? So since e power x not equal to 0, cos x plus sin x is supposed to be 0. Okay, so that implies cos x equal to minus sin x. Okay, we need to solve this. For that, what we can do is we can divide both sides with the cos x. So we get 1 equal to minus sin x by cos x. This minus we can give to the other side also. So 1 equal to minus tan x or minus 1 equal to tan x. Both are okay, right? So tan x equal to minus 1. So what is the value of x here? We need to find out. We know that tan 135 equal to minus 1, right? I mean tan 3 pi by 4 equal to minus 1. So this implies tan x equal to tan 3 pi by 4. That implies x equal to 3 pi by 4. And obviously this 135 will be in the interval 0 to 180 degree, right? Pi is 180 degree, right? So 0 to 180 degree will contain this point. So if we take the interval between 0 and pi, okay, 135 or 3 pi by 4 will be somewhere here. So the function will behave different in the left side of 3 pi by 4 and will behave different in the right side of 3 pi by 4. That is the nature of critical points, right? So we need to take one point in the interval between 0 and 3 pi by 4 and check the nature of the function. Okay, f dash of x. Same way we need to take any value between 3 pi by 4 and pi to check the nature of f dash of x. Okay, so in between 0 and 135 we can take 90 degree, right? So we can check that. Let x belong to the interval between 0 and 3 pi by 4. F dash of x is equal to, if x equal to pi by 2 particularly, then f dash of x will be e power pi by 2 into cos pi by 2 plus sin pi by 2 So this will be e power pi by 2 into cos pi by 2 is 0, sin pi by 2 is 1. So this is going to be e power pi by 2, which is always positive because e power x can never become negative, right? So this is always positive. And let us take any other value in the interval 135 to 180. Okay, let us take 150 degree for example. Okay, 150 degree will be somewhere here, right? And 150 degree is 5 pi by 6, right? So we are going to take x equal to 5 pi by 6 and check the nature. Let x belong to the interval 3 pi by 4 comma pi. In particular, if x equal to 5 pi by 6, let's see what happens. F dash of x equal to e power 5 pi by 6 into cos 5 pi by 6 cos 5 pi by 6 plus sin 5 pi by 6. So this will be e power 5 pi by 6 into cos 5 pi by 6 is cos 150 degree, right? Cos 150 degree is the same like cos 30 degree with a negative sign. So it will be minus root 3 by 2. Okay. And sin 150 will be the same like sin 30 with a positive sign, right? And sin 30 is 1 by 2. So sin 150 is also 1 by 2. Okay. So here it will become minus root 3 by 2 plus 1 by 2. Okay. So this will be like e power 5 pi by 2 into, if 2 is taken as LCM, root 3 is 1.732, right? So minus 1.732 plus 1 by 2. This will be a negative quantity, right? Why? Because minus 0.732 by 2 will be obtained in the brackets. That into e power 5 pi by 6 is always positive. So positive into negative will always give us a negative quantity, right? So now let us check. F dash of x is always positive on the left side of 135 degree and a negative on the right side of the value 3 pi by 4, right? F dash of x is greater than 0 in 0 comma 3 pi by 4 interval, and f dash of x is less than 0 in 3 pi by 4 comma pi interval. That implies f of x was increasing in the interval 0 comma 3 pi by 4 and decreasing in the interval 3 pi by 4 comma pi. That's what we need to do in this sum. Okay. So let us move on. The second subpart of this question is verify whether each critical point when x belong to 0 comma pi is a point of local maximum or local minimum or a point of inflection. See, finding the critical point is already done. We got only one, right? Remember that. So f dash of x was already found, e power x into cos x plus sin x, and f dash of x equal to 0 implies x equal to 3 pi by 4. All these parts are already done. We don't need to do this once again. That is enough. Now it is just asked whether 3 pi by 4 is giving you a maximum point or minimum point. That's what we need to check here. So let us do that by applying the second derivative test. So we need one more derivative of f dash of x here. Again we need to apply UV method. E power x is taken as the first function. The entire value in the next bracket is our second function. Let us apply UV method carefully, keeping e power x idle. Derivative of cos x plus sin x will be minus sin x plus cos x, and keeping cos x plus sin x idle, e power x's derivative is e power x. Okay, we will expand this. E power x can be taken common from both of them. So we get minus sin x plus cos x plus sin x. And here minus sign and plus sign will cancel each other. So this will become e power x into 2 cos x. Okay, this is our f2 dash of x now. Now we have to put x equal to 3 pi by 4 and check what is the sign of this second derivative, right? So if x equal to 3 pi by 4, f2 dash of 3 pi by 4 equal to e power 3 pi by 4 into 2 into cos 3 pi by 4, right? So this becomes e power 3 pi by 4 into 2 into 1 by root 2, minus 1 by root 2. Okay, and that will give us minus root 2, right? Which is going to be negative. How do we know that? Because e power 3 pi by 4 is always positive. So when the second derivative gives a negative answer at that particular point, then the particular point obtained is a maximum point, right? So therefore x equal to 3 pi by 4 is a point of local maximum, right? That is our conclusion. That's the end of this paper. Thank you. Hope this video was really helpful for your revision of concepts. Do share this video with your friends. Please stay tuned because we are going to solve many previous year papers together. Until we meet in the next video, happy learning.